Hello. On behalf of our sponsors, the Metropolitan Water District of Southern California, the Municipal Water District of Orange County, and the Water Energy Education Alliance, we would like to welcome you to our workshop, Solving Water Problems in the 21st Century, teaching biology, chemistry, and physics through water. We are so glad you're here.
So here's our agenda for today. We do have an exciting day planned for you. We have a break in there as well, but we're all adults. So if you need to step away, just turn off your video and go step away and do whatever you got to do to come back. We have a 15-minute break between the two examples that Juanita is going to teach. And now I'd like to move on. Let's see if I can get it to advance. There we go. Now I would like to just give you an introduction to our facilitators, which you probably know Juanita, but you don't know me and you probably don't know Dr. Steele. Yeah. So I'm Allison Loki. This is my little group that I put together. I have worked in the water industry for over 20 years. I've done everything from legislation to community affairs to be the person who runs the mail. I turned water on and off. I bought and sold water. And just like Tiffany, I came to this position backwardly, right? I was in school and I needed to get a new job, and I started working as a customer service rep, and it was an excellent career choice. So not only do we want people to know more about water and so there'll be better citizens, we also need people to come into the workforce. On this side, I've been writing curriculum, newsletters, technical documents for about 7 or 8 years, and I've been teaching at Valley College for almost 8 years now. So I teach water resource management and water use efficiency. So you have my contact information. If I can ever help you, please let me know. Then I would also like to introduce Kathleen. She will be doing part of our presentation today. And really, Kathleen is the beginning of this idea. It was the little idea that was in her brain that got everything started. If it actually hadn't been for her, it would have never gone forward. She is also adjunct faculty. She's now retired from this San Bernardino County ROP, and she's adjunct faculty at Cal State San Bernardino. And then there's Juanita. I've known Juanita since the beginning of this project. Juanita is probably the most caring, passionate teacher I've ever actually had the pleasure to know in my life. She is a little whirlwind. She's hard to keep up with, and you really got to stay on your toes. But she really cares about her students, and she's put so much time and effort into teaching her students science as well as the water curriculum. The woman just basically never sleeps. So I'm deeply honored to work with these two ladies on this project because honestly, I've worked in the water industry. They know a lot more than I do. They've taught me a lot throughout this process. So without further ado, I'm going to move forward, and I think this is now on to Kathleen. Oops, went too far.
It's on me. So hi everybody. And I have to say, as Allison's mentioned, over the course of the years, Juanita and Allison and I have become very good friends. And I know I've always loved Allison, but I love her even more by using a photo that's at least 10 years old and, doesn't look anything like me anymore. So yeah, thank you, Allison. If only I had that face, that would be good. We're going to do thanks. We're going to do a quick activity called Above the Fold. And let me explain what we will be doing in just a couple of minutes. You're going to go into a breakout room with a few other people, and you're going to look at an image assigned to your group number. So if you are in breakout room number 1, you're going to look at slide number 1. And what you're going to do is look at this slide, and you're going to determine a headline that would be appropriate for that particular image. And I have to tell you, all of these images relate to water in one way or another. And you've got about 5 minutes to do this. And just a little note and a hint is that headlines are usually 7 words or less. We don't want a real lengthy one, 7 words or less, and try to make it as catchy and eye-catching as you possibly can. So let me see if I can even do see, I can't go through them. There we go. Group 1, this is your picture. Group 2, that's yours. 3, 4, 5. I love those cows. And 6. Okay. The link is in the chat.
Yes.
Okay, the link is in the chat. And if we can go to our breakout rooms now. You'll be able to access the images. I'll set the timer for 5 minutes and I'll check in with you to make sure that you know what you're doing. Again, you're going to create a headline for each of these images. Okay. So for some unknown reason, we're all teachers here. And for one reason or another, I cannot read what's on those slides. And honestly, last week I had my eyes checked. I should have had my head examined, but I had my eyes checked and I can't read. I cannot read what's on the screen at all. So I have no idea if I'm hoping I'm not having a stroke, but somebody call 911 if I fall on the floor. So group one had an interesting image. As you can see here, it says no boating. And I think that's pretty clear. So somebody from group 1, can you read that slide for me, the headline?
I can. It says lake is left high and dry.
Lake is left high and dry. You could work for a newspaper. That is an amazing above the fold headline for that article. Absolutely. Lake is left high and dry. Awesome. Thank you very much. Moving on to group 2. Somebody read that one for me, please.
Sure. Angelinos begin battle for last bits of water.
Last bits of water. Angelinos. Absolutely. Thank you for that, Andy. And that's a perfect example of what we're facing right now with the water crisis. We know that with the drought, more and more of our water reservoirs are starting to look just exactly like that. So thank you very much, group 2. Good job. Group 3, somebody can read that for me, please.
The future of SoCal water, desalination.
Desalination. Yes, I think that's exactly going to be one of the cures for what ails us here. The future of SoCal water, desalination. Awesome. Very good, group 3. Thank you so much for that. Group 4. What do we got here for group 4?
It says Watertown. Where's the water coming from? Who knows?
That is perfect. And I think this was out by Las Vegas. And we just keep building and building and building without regard and thinking about the long-term implications of increased population. And
Yeah, we just noticed that almost every house has a pool as well. So
exactly. Well, if you live out that way, you need a pool.
Yeah.
So let's look at, thank you so much for that, group 4. And group 5, our famous cows. What do we have here?
they're cute.
Can't get the milk without the water.
Can't get the milk without the water. How true is that? That's a perfect headline. Again, you could all be working for the newspapers for sure. And last but not least, group 6. What do we got?
We have flood irrigation dries up.
Flood irrigation dries up. Absolutely. We know, and I think Allison's going to touch on it in just a minute, that at least or very close to 80% of our water in California is used for agriculture. And so when we start thinking about we need water for food, and yes, we do, of course, but looking at alternative ways of irrigation and providing water to the plants and trees that we rely on is going to be where we're headed next. So thank you for that. That was really fun. I hope it was fun for you as well. So Allison pointed out too that, and she did mention that it all started with little old me. And in a way, it really started with a random piece of paper. And I was at a business meeting at Valley College, and I happened to be sitting somewhere and I saw this little brochure for the water supply technology program that they have at Valley College in San Bernardino. And I was thumbing through it while I was waiting for the meeting to start, and I was astonished because if we can look at the next slide, I can't make it go. There we go. And maybe you can see this. One of the things that was eye-popping for me was to see the difference between a college degree and a certification in the water industry. And I looked at these numbers and I was really, really astonished that you could, with a certification from Valley College, an entry-level position in a water industry is about $55,000. And then with 5 years and so forth, 5 years of experience, you're up to over $80,000 a year. And to get a water certification at Valley College, and Allison can correct me, but it's a year to a year and a half of coursework that you would take in order to be able to be an entry level employee in the water industry. And for me, I stopped in my tracks and I thought, well, you know, I'm from San Bernardino and Rialto and Fontana and San Bernardino and these areas. People struggle. And $50,000, $80,000 are game changers, not just for them as young people, but also for their families and their extended families, and then also through to the community. And so I wanted to do something about it. And I can't, for whatever reason, make it move forward. So somebody, Bryce, can you do that, please? So basically what I did is I went to find a little bit of money and we made a few friends, and I wrote a couple of grants. We got some money to write some water curriculum. I met Allison, I met Juanita, and we put our heads together and we really wanted to run with how do we provide high school students with a solid foundation to enter into the water program and take advantage of this wonderful opportunity for changing their lives. And so that's what we did. The next slide is, please, I think our coursework. So we wrote 3 science courses. Juanita's going to talk more about that later. We also ended up over the course of a couple of years writing 3 CTE courses. One of them focuses on GIS. One of them is a technical course that leads to certification. And so when students are 18, they're able to take one of the water tests to become certified. And then actually the next one, Get in the Water, is another certification for students as well. So what we wanted to do was to develop a pathway. And as you can see, we've done a pretty good job of it with 6 courses, and there's actually 7. One is a water wars, econ, and government class that meets A through G requirements. So that's where we came from in a nutshell, and that's what we did. And you're going to be able to reap the benefits of that today as we turn it over, I think, to Allison. Are you next on the hit parade, or is that Juanita?
I am next on the hit parade.
Okay.
All right. Thank you so much, Kathleen. So Kathleen did a really nice job of setting me up for this. I'm just going to give you a little background water knowledge, because it is possible that although you're science teachers primarily, you're missing a little bit of basic water knowledge. So this is just a very simple overview. I always like to talk about the population of our state, which is fast approaching 40 million, but 30 million of us, a little more than that, live below that red line that I have across the California map. That's where we all live, is in Southern California. A little less than 10 million live in Central and Northern California, which is where the water is. Of course, the Central Valley is primarily agriculture. So of all the water that we use in our state, about 80% goes to agriculture. Only about 20% is used for urban use. And of that 20%, especially during the summer, about 70% of that goes to water grass. So people always want to think that it's pools that are the problem. It's not ever a pool, it's always grass. So all of this water drives the 5th largest economy in the world, right? It's critical for us to manage our water supplies well. As Kathleen mentioned, and I'll show you some headlines in a moment, it looks like we're about to go into another drought. We barely recovered from the last drought. Another part of California is that we not only have the most variable precipitation patterns of a state, from 2 inches in the Mojave to 92 in Gascay, which is clear in the very tippy top corner of Northern California on the coast. We also have the most variable water patterns year to year. There is no average annual rainfall. And to give you a better example of that, I've been in water a little bit over 20 years. It's not unusual for us to have 2 inches of water one year and 36 the next year, and then maybe go several years and have 2, 3, or 4 inches, and then multiple inches the next year. So we have to manage our water by pumping it back into reservoirs, pumping it back into underground aquifers so that we have it for the next dry spell. The other interesting thing is all of our population centers are actually pretty far from water, right? So we have to move water to where the people are. The single leading factor for all of us living in Southern California basically is the weather. That's not going to change. None of us are having a mass exodus and moving to another place. So we will have to continue to move water from other states and within our own state to supply our water needs. Move forward. There, oh, too far. There we go. There we go. Let me make sure I didn't go too far. Why does it not wanna? Okay, wait, no. Okay, wait, sorry about that. We're having a little bit of a, hey, Bryce, can you just advance? There we go. Thank you. I don't know why mine's glitching. So if you don't work in water, you may not understand how water actually works, right? So water providers have different names. In California, you have public and private water providers. If you have a city, if your water comes from your city, like mine does, I live in Riverside, that's obviously a public water provider. I can vote for that board. I have direct control. I can make a protest. I can go to a meeting, etc. If you live in Claremont, you might be part of Golden State Water, which is a private water company. And there are a surprising number of private water suppliers throughout California. Now, not as much as there is throughout the rest of the country or throughout the rest of the world, but not all water providers are public. So sometimes we're cities, sometimes we're called an agency, and sometimes we're a district. My last job was for a district. To make that even more complicated, some of us are wholesalers, some of us are retailers. So Metropolitan Water District of Southern California, one of our sponsors, they're a wholesaler. They never touch a retail customer. They supply their water to MoDOC, who is another sponsor. They are a retailer, okay? I've always worked for retailers, to be honest. I've always worked for somebody who actually supplies the customer. So it makes it confusing for regular people to understand that there are both public and private, and we all have many different names. Okay, that's part of the, I think, the challenge in creating an understanding. No matter who you are as a water provider, you rely on different types of supply, and you can have two suppliers literally next door to one another, divided by a street, and they may have entirely different types of supply dependent on their water rights. But here are the different types of supply. Groundwater is by far the cheapest type of supply. It's easy to pump, treat, and distribute to all your customers. Surface water is great. If you are next to a creek or a river that actually you have rights to, you have to treat that water differently. It's very drought dependent, because what dries up first in a drought is surface water, right? Your lakes and your streams start to go dry. Groundwater reacts slowly to a drought. It rebounds slowly to a drought. You have recycled water, which is purple pipe water. There's a lot of that in Orange County. It has, people are resistant to this, but it's actually a great drought-proof supply. And it's essentially where you take wastewater and you treat it to drinking water capacity, and then you repipe it. When I say Orange County has some of it, nobody has direct toilet to tap. No one that I know of has that. But what they do is take recycled water and they pump it back into a groundwater aquifer. And in many places, they take recycled water and they use it for irrigation on parks or large commercial properties. It saves potable water from being used for irrigation. You saw the picture of this salinized water. That is the most expensive form of water. It's even more expensive than recycled water. So while that may at some point be a useful supply, it's highly unlikely for the next decades, several decades, because everybody wants cheap water. They don't want to pay for water, and you could hardly get more expensive than desalinized water. Not saying it's never coming, but in California especially, you have to pass through a lot of environmental regulations. That's super difficult to get through. Imported water is an interesting animal. We call it imported water if it's not local. So I can be in Southern California and import water from Northern California. We still call it imported water like it came from the moon. It could be from the Colorado River Aqueduct. It could be from a myriad of sources, but it's imported if it's not directly in our own backyard. It is also expensive and very infrastructure intensive. So when you talk about infrastructure bills maybe passing, part of that will go to water needs like repairing imported water infrastructure, maybe building recycled water infrastructure. So that's a part, very infrastructure intensive. And then shockingly, or maybe not so much, conservation is now considered a source of supply. If you can reduce demand enough to free up water for actual needs, for example, if you can get people to convert part of their landscape to native plants that don't use quite so much water in aggregate form, that is now considered a source of supply. So you'll notice that people are putting a lot more money into conservation programs. There we go. So we are about to go into, it looks like, another drought cycle. The last drought was from 2012 to 2017. And droughts have a true economic impact for all of us. And we'll get into that in a minute. But California is extremely drought prone, right? We've had 9 significant droughts since 1840, some of them more than 5 years long. So here's some example of some of the headlines that we've had. Let me see if I can get that to move forward. Maybe. Hello. There's one. And Bryce, there we go. There's our headlines, right? These are pretty critical, and then we stop, right? These are all headlines just since June, okay? The first one deals with agriculture. Nobody wants to cut off the water to agriculture. We all need food. The agriculture in California is such a large business that 1 person in 5 eats something produced in California every single day worldwide. Okay, it's not just for us, it's for the entire world. Agriculture is critical. You saw that Governor Newsom asked all Californians to voluntarily reduce their water usage by 15%. Many people already did that during the last drought. What was shocking was that during the last drought, we asked people to reduce, and guess what? They did. They responded. Most people have not rebounded to their previous water use levels. So if you've already reduced your water usage quite a bit, it's hard to find another way to reduce your water. So this is something we all have to think about. Droughts have terrible impacts on the environment, right? It's not just people, it's the environment. In California, the environment and people are co-equal goals legally, right? There's not one above the other. If there is water to be allocated, at least half of it will be going to environmental concerns. That is the law in California. So when you see something that says nearly all salmon could die in the Sacramento River, this is going to have an impact, because if they have the opportunity to funnel water from somewhere else, they will. Legally, they are obligated to. Lake Mead, Lake Mead. Okay, so Las Vegas, all their water comes from Lake Mead. They have almost no groundwater, almost no other supply. So if you want to have a city that's super reliant on Lake Mead, Las Vegas would be the one. But they also use it for hydropower. Okay, so without hydropower, I mean, what's going to happen not only to us, but to cities like Las Vegas? Hoover Dam supplies about 1/5 of the electricity for Southern California. If Lake Mead is dry and you can't pump, you can't run those generators, it's going to impact our electrical capabilities as well. And then the last one just came out. Kathleen sent me this. She's great for sending me articles. This has to do with Needles. They're down to one water well. That's it for the whole city. As hot as it is in Needles, I mean, now we're not even talking about keeping landscaping alive. We're talking about keeping people alive. So these are all considerations for us as the next drought looms. Move forward. I don't know why this is being, there it is. So this is a nifty tool that we use in conservation all the time. And this is called the US Drought Monitor. You can get this for any state. And during the last drought, we literally printed one of these every single day of the drought for 4 years. And we took my office and we papered them all the way around the room. So we had a picture of how bad it got. I pulled this up on July 22nd, right? So not even a week ago. And you can see where we're at with, well, there's no part of the state now that is not in a dry patch. Most of the state has gone to extreme drought, and some of it is an exceptional drought. This affects our ability to grow food, but it also affects our ability just to have so many other uses. I would encourage you, I put the URL up there. I would encourage you to use that on your own. It's kind of a fun thing to look at. So what are the drought repercussions? I took some quick notes here. In economic losses are unbelievable. In the years 2014 to 2016, the drought caused agriculture to lose $3.8 billion in revenues. Now, I'm not saying that they didn't make a profit or that they didn't survive it, but that is a huge economic loss. You also have environmental losses like tree deaths. You can see in the picture on the right, we lost a lot of trees during this last one. The best estimate I've seen is 102 million trees died during the last drought. They just don't have enough water to survive. Fish gill is another problem. California supports 129 different species of freshwater fish. About 2/3 of those are found only in California. So when you have low and high flows and temperature variations, you're going to lose a lot of our native fish, let alone other fish. We already talked about hydropower shutdowns, but production was cut in 2014 to 2015 due to the drought by 50%. The problem is you've got to get power somehow. If you're not using hydropower, then you're going to get it somewhere else. And that would be using gas turbine generators, which causes more carbon emissions, which is more difficult for us. It causes greenhouse gas as well. I'll get to that. Land subsidence. The picture at the bottom is a really good example of land subsidence. When aquifers sink because they're over pumped or they're not refilled as nature intended, things shift. And what you have is land subsidence, which is what you're seeing. Eventually that's got to be fixed, right? That costs money to fix infrastructure. It's not just roads, it's wells, it's people's houses. Subsidence is always a bad thing. We talked a little bit about urban users having to cut back. I'm not sure, like I already have in my case. I'm a water conservation person. I have no grass anyway, because they'll throw me out of the club if I do. But where would I cut back? I already have entirely native plants, you know. There's a lot of people out there like me who've already done their best to be good water stewards. And rural people will literally run out of water, much like happened during the last drought in Central California, where folks don't even have drinking water. So the drought coming is real. We hope that you'll use these lessons to educate your students and help them learn about water and what we can all do to move forward in a more productive manner. And I think, let me see. I think,
Allison, I see a question in the chat and I think it's really good. It's from Patricia. She says, is it harder for the water table to fill again once it subsides and collapses?
no, not typically, as long as it hasn't been over pumped. It will happen naturally over time. Some places are really, really good about funneling floodwaters into those channels and getting them right to a groundwater basin. I've worked at a couple of cities where they did that. But no, if it hasn't been over pumped and been crushed, then no, they fill up. It's just very slow to fill up. And it's not a very exact science either. Like we check, typically a city or agency will check their wells every week to see if they're dropping. And you can watch them rebound. They're slow to react in drought. They're slow to come back after drought as well.
Excellent. There were also a couple of comments in the chat about receiving a copy of the presentation. And I think that you definitely will get a copy of the presentation. There's been more than one comment there.
Absolutely. That is correct. So thank you, Juanita, for jumping in. It is now Juanita's turn.
Hey, don't start cheering all at once. I mean, okay. Clover wanted to clarify in the chat after subsidence. Clover, maybe you want to unmute and explain a little bit more what you meant. After subsidence, it is more difficult for the water table to fill again, or what are you saying?
Can I jump in there? Yeah.
Yeah, of course.
If you crush a groundwater aquifer, so really what happens in an aquifer is it's not the space holding the water up. It's the water holding the dirt up. The water creates pore spaces inside an aquifer. So you've got this nice layered aquifer, right? If you crush it by over pumping it and pulling all the water out and the land drops, you can't refill it. It's not like a sponge where it just like, it doesn't work like that. You pretty much trashed your aquifer at that point. That's why we have to be very careful to not over pump to where we cannot replace. I think that probably answered your question.
There's no need for me to say anything. My instructor answered it exactly as she taught me.
Thanks, Chloe.
Thank you, Clover. All right, so now we're going to jump right into a conversation about the courses and about some curriculum pieces that if you are not teaching the courses all the way through, then maybe you can find some pieces of curriculum that would be helpful to you. So I don't think I have co-host features, Bryce, but that's fine. You can keep those co-host features as long as I can share. Can you move forward to the next slide? So my name is Juanita Chan. The slide previously said that I'm the STEM coordinator, but now I am the agent of science and career programs for Rialto Unified School District. And what that means is that just means that I do science professional development and I help to support the science teachers TK-12 as well as all of our STEM initiatives. We have a huge environmental literacy initiative. We are one of the few districts in California that the board has actually signed an environmental sustainability board resolution. We won the U.S. Department Green Ribbon Schools District for our work that we've been doing with environmental literacy and environmental justice topics. And so we are really, really invested in this idea that we want to build up climate warriors, not just climate people that are environmentally literate, but people that are ready to go out and do something about that. As a result, what we ended up doing was we ended up really thinking about both college and career options for our students as they matriculate up and out of the system. And when Dr. Steele came to us and Allison came to us with this great idea for these these water courses, we wanted it to be really efficient for our students. And so the way that we figured out that it could be the most efficient is by working with UCCI, the University of California Curriculum Integration Project, to make a set of courses that could both give students college readiness and career readiness. So by college and career readiness, what this means is that these set of science courses are integrated science courses. It's a 3-year sequence, and students receive both science D level science credits. So it used to be Lab D Science, and so UC Regents has changed some of their language recently. So D Science credit for the A through G requirements, as well as CTE designation. So they're designated as both CTE courses and science courses. And so in UC Doorways, the courses are called Solving Water Problems Through Integrated Science. This course is really our entry-level course. It's designed for 9th or 10th graders. Then it's Integrated Science and Water Technology. So if you're looking at the grade span, it's 10th, 11th, and 12th. And Principles of Water Applications. And that is the year 3 integrated class. And so if you're thinking about it, then you would see it in the 11th or the 12th grade. If you were interested in the transcript abbreviations, I'm not exactly sure who's on the call and what level in the organization that you belong to, but these transcript abbreviations are helpful if that is part of your role. Notice that they're all D Science classes. They all are considered full lab classes, and they're integrated science classes. We think that these classes lead up in a really nice way to AP Environmental Science, because we're really promoting science like for all 4 years in high school. All right, next slide. If you are a science teacher, then this document is not new to you. If you are not a science teacher, you're probably looking at this document and thinking, oh my gosh, that's a lot of colors. This is a very colorful document. It's full of flair. Let's call it flair. So I want to talk for just a second about the next generation science standards, and we're going to call those the NGSS. The NGSS standards are written in such a way that there is just a lot of information condensed into a very small footprint. Juan in the chat, it was Rialto Unified that I was with. Yes, it was. It is. That's what I'm with. So each standard is broken down into a performance expectation, and the performance expectation is exactly what it sounds like it would be. It is the expectation that we would expect for a student to be able to perform. That being said, it's written so that it's a statement about what a student is able to do after instruction occurs. So you'll see that all the performance expectations are actionable statements. It's not just some kind of theory. And they're made up of 3 different dimensions. That's why people say that the NGSS are 3D. So those 3 dimensions are listed in the foundation box. One is the science and engineering practices. Pop quiz, anybody put in the chat, how many science and engineering practices are there? Do you know? I'm going to give you a countdown. 5, 4, 3, 2, 1. Ooh, Irene, she knows. Edna. Oh, Dong, he was pretty close. Dennis, pretty close. There are 8 science and engineering practices. And then the disciplinary core ideas are those orange sections. The disciplinary core ideas are statements about like the science. I hate to call them science facts, but they're science, the content. A lot of times when I'm doing stuff with NGSS, people are always saying, oh, but they took all the content out of the new standards. If you are really looking for the what, that would be the disciplinary core ideas, and they are listed in the orange. And then the last one is the cross-cutting concepts. The cross-cutting concepts are training our students' brains to how to think about these scientific ideas. So what the real shift is the shift is that we are switching from teaching students just discrete facts about science to teaching students how to think about science. And as we've been coming through this pandemic, I know that I've been reflecting quite a bit about people's just scientific literacy. And I'm like, man, this is an indictment on on instruction here, because people should know that science, it's all.
I lost Juanita.
I lost her too.
Yes, she
Very
froze.
careful observations.
There she is.
There you are.
Oh,
You're
I'm
back.
frozen. Oh, I was supposed to say. Can you hear me now?
Yes.
The last thing, the first thing we heard again was observation. So we missed a good little piece of
Okay. Can you hear me now?
Yes.
All right, excellent. Okay, yeah, building the suspense. That's right, Dong. I'm just adding to this air of mystery here. No, but science is really our human endeavor, and we are striving to better understand and communicate about the natural world around us. And so our biggest task is to help for students to understand that as well. So our science knowledge grows and changes based on technology. It changes based on our understanding of natural phenomena. And so really what you'll hear over and over when you start talking about science is you'll hear phenomena, and that your phenomena does not have to be phenomenal. It can be something that people think that they already understand. You go outside, you look at a tree, but all of a sudden you start asking questions about that tree that causes somebody to make more careful observations and be able to communicate more articulately about that tree using all of your senses. That's right, Patricia. Phenomena. Da, 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 da. Anyway, in these boxes, underneath those foundation boxes, you have the connection boxes, and the connection boxes connect the science standards with the Common Core state standards for English language arts and for mathematics. So as we go through today, we're really going to be striving to make those linkages for you, and I'm going to show you what some of the example content from the courses looks like and how that might help in your science instruction. Next slide. Along with the science standards, we're also going to talk about California's environmental principles and concepts. These are called the EP&Cs. Have you seen the EP&Cs before? Can you just put in the chat? Let me just hear from you. Yes, no, maybe so. Yes, no, maybe so. Yes, no, maybe so. So I see some no's. One yes. I only see 3 so far. No, yes, familiar-ish. No, yes. Okay, good. So this is new for you then. Perfect. So the California's environmental principles and concepts are a piece of legislation that are not a part of the standards, but they were adopted by the state of California. And the governor, prior to Governor Newsom, which his name is escaping me, and he was governor for such a long time. Jerry Brown. And there it is. Jerry Brown, and the state superintendent before Tony Thurmond was state superintendent. Well, anyways, they worked on there was a committee that was put together to come up with these pieces, and we are supposed to be teaching them. They are referenced in both or in all of the California frameworks. They're in the science framework, they're in the health framework, they're in the math framework, they're in the English and language arts frameworks. Tom Torlakson, thank you, Irene. That was going to bother me all day. Tom Torlakson. Anyway, these environmental principles, there are 5 of them. And basically, they are California's attempt at making sure that all 6.2 million students that we educate can leave our K-12 system with an understanding of environmental topics. So principle 1, I'm not going to read them all to you, but what you should know is that our health depends on the health of our natural systems, the long-term functioning of different ecosystems. There's a relationship, whether we want it or not, with those human societies, that there are natural cycles that we both benefit from, we depend on, and that we alter. Our actions alter. Principle 4 is that these natural systems and human social systems affect long-term functioning in both. And the last one is that decisions affecting resources and natural systems are based on a wide range of considerations and decision-making processes. EP&C number 5 is my very favorite one. You can reference it with every single water lesson that you do. It's basically saying that, when people start talking about environmental literacy, it's like, ooh, people are bad. We only do bad things. But really, it's the idea that people impact our natural systems, but we can have a negative impact, but we can also have a positive impact, and our impact can be neutral. So if we were really trying to convey anything to students as we're going through this, if you're going to strive to really let one of these EP&Cs infuse what it is that you teach on the daily basis, I would really emphasize principle number 5, that humans and human social systems can both impact the environment negatively, positively, or in a neutral way, because that's how we have to change those mindsets. All right, next slide. Maybe you're not a science teacher. Maybe you are a CTE teacher, or maybe you're a science teacher and you're like, CTE, what is that? The people that bake the cookies? No, it is not. It is so much more than the people that bake the cookies. So CTE stands for Career Technical Education, and Career Technical Education is why California changed their language from just like college ready to now college and career ready. The idea is that our classes that we're offering students are going to prepare them for employment, post-secondary opportunities that would allow them to, take care of their families and themselves in a way that is, respectful and allows for some positive momentum. And so that being said, it goes back to what Dr. Steele was saying earlier about jobs. Am I frozen again? In the water industry.
We can hear you, but your video is
frozen. Okay, my video is frozen. Okay, that's okay. Jobs in the water industry. So these set of classes fall into a CTE cluster that goes along with energy, environment, and utilities. Energy, environment, and utilities. Next slide. And if you come to the next session will talk way more about this. Now, it's very easy for me to fall into the alphabet soup because I've been doing this for a little while. So I wanted to just give you a quick acronym rundown. NGSS, performance expectations, PEs. SCPs are the science and engineering practices, CCCs, cross-cutting concepts. Those are the 4 different disciplines of science. NOS, which sometimes you don't hear, but the nature of science is so important. That's what I was talking about as science as a human endeavor. The EPNCs, CA, CCSS, which are the California Content Standards. And we are going to talk about CCR, CER, and we already talked about CTE. Excellent. Let's move on. Are there any questions? Are there any questions about that? No? Yes? All right. Well, to move us forward, I thought it would be great to play a little game. You guys are teachers. We did distance learning all year, so I'm sure that you are familiar with Kahoot. Are you familiar with Kahoot? Mm-hmm. Yes, definitely. All right, we're going to play a little Kahoot game. Let me just share my screen. This will stop other screen sharing. Do you want to continue? Yes, I do. Let me see if I can get my applications going here. I'm going to try this one. Let's see. Kahoot. Here we go. You guys see the Kahoot game pen? All right. If you can see the Kahoot game pen, then if you are familiar with Kahoot, you're going to go on another device. You're going to type in, or at a different tab, you're going to type in www.kahoot.it. And then once you get there, it'll ask you for your game pen. Bryce is already here. Welcome, Bryce. 9060639. Trish, hey, what's up, Kat? Nice to see you, Dave. Welcome in, Lizette. Alice, good seeing you. Dennis, Andy with the cool glasses. Maze is all about the money. Irene is ready and raring to go. Giovanni, he's in. Let's see. Oh, let's turn up the music. Everybody loves the Kahoot music. Oh, yeah. Asmao, there it is. Can you guys hear the Kahoot music?
No.
Oh, that's
you need the sound as well.
I have to share the sound as well. Oh, that was the problem before. Okay, well, forget that. All right, we're gonna start. I don't think that's everybody. 1, 2, 3, 4. Oh, there's Donna. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's pretty close to everybody. 14, Edna. Oh, so you didn't want to start without Edna. Wait, hold on. Where's Clover? Clover? Wait, Clover. Augustina, thank you for joining us here. 15.
Clover's phone is still installing Kahoot.
Okay, Clover's phone is still installing Kahoot. Okay, so we got 16. How many total people do we have in this?
23.
23? Okay. 16, I have a 2/3 rule. If 2/3 of us are here, somebody just take down the game pin. If you haven't been able to log in yet, just take down the game pin. It's 9060639. There's Juan. Hey, Juan. Okay, we're going to get started. Are you ready? Yep. All right. Earth's hydrosphere. 3, 2, 1. These are yes or true or false questions. The Big Bang is the starting point from which all matter and energy within our universe arose. True or false? We got 20 seconds. Let's see. Okay, let's see. Ooh, you guys didn't need all 20 seconds. Oh. Hey, see. The answer is true. The Big Bang, a starting point. That is what the standards say. Definitely. All right. Bryce, you were first. Giovanni in with a quick second. Okay, let's keep going. Good job, guys. According to radioactive dating and other pieces of evidence, the Earth formed around 3.8 billion years ago. True or false? I wish you guys could hear the music. It makes it so much more suspenseful, but I don't know how to do that. So I kind of messed that up. Sorry about that. There's 8 questions in this game. Let's see. How do we do? Wah, wah, wah. That one was false. So according to science, the Earth is about 4.6 billion years old. Let's go. What's next? Oh, Bryce. Oh, no. Augustina. You were first on that one. Alice, Asmal. There you go. Let's see. Let's keep going. True or false? Water on Earth's surface came from particles and rocks that originated in volcanoes. Let's see. Let's see. What do we got? What do we got? Everybody's almost answered. Almost everybody. Let's see. 9. The music's so fun. Oh, false. And that is correct. That is false. So they think that most particles came from asteroids and solar nebula. Let's see. Let's see. Who knew that? Alice. Alice knew that right away. And so did Osma and Donna. All right, ladies. Okay, gentlemen, you got to step it up. These ladies are getting pretty quick here. True or false? The water cycle describes the intermittent movement of water on, above, and below the surface of the Earth. Isn't that a pretty picture? Whoa. That was fast. Everybody said true, but this one was a trick question because of the term intermittent movement. It's actually the continuous movement. That was a trick one. Let's see who got it. Osmo. Osmo got it. All right, let's see. True or false? The abundant supply of water vapor in the atmosphere condensed to form our oceans. Oh, it's not as fun without the music.
No,
No, it's not as fun without the music, but you know,
it's all right.
too bad. That's all right. That's okay. I wish I could play something. We got 3 seconds left.
Sing, Juanita.
You want to sing? Yeah.
No.
Dun, 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 dun. Okay, let's see. The correct answer. We got 7 truths and 9 falses. The correct answer is true. Let's see who got it. Oh, Osmo is totally in the lead with Giovanni and Dennis. Okay, the gentlemen were like, they took it to heart. They were like, bam, I'm going to do this. Look at up 5 places. Maze, you're the highest climber. Number 6, true or false? The early history of the hydrosphere is closely linked to the theories regarding the origin of Earth. True or false? Do, 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 do. What? You said sing. I was singing.
Da, da,
Yeah.
da, da, da.
There, oh, the Jeopardy theme song. Oh, that was true. We got 12 truths and 3 falses. Let's see who got it right. Let's see who's in the lead. Scoreboard says Osmo is still in the lead. Giovanni is sticking up there with you, though, and Alice is making a comeback. Let's see. Number 7. True or false? In the Big Bang, it was believed to have cooled to allow the formation of atoms and then elements, primarily oxygen.
Osma's killing it.
Osmo is totally killing it. Maybe she was an earth science teacher?
Maybe.
What would these? Yeah, Osmo, we want to hear from you. Were you an earth science teacher back in the day? Or maybe now? Maybe you're still an earth science teacher. Maybe we just know a lot about the earth. Oh, no. Oh, this one is another trick question. Cooled the formation of atoms and then elements primarily. It wasn't oxygen. Where are my chemistry teachers at? It was primarily what? Come on, chemistry teachers. Primarily? I'm going to let that one dangle out there. All right. Osmo is still in the lead. Augustina and Maze. knocking Giovanni out of second place. Let's see. Last one, number 8. True or false? The saltiness of the oceans was attributed to the dissolution of minerals that came from rocks. 18, 17, 16. This is the time when you do the Jeopardy theme song, Allison. Now's the Jeopardy theme song time because it's our very last one. Dun, 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 dun. What happened? Who's that? They saying something. I want to know. Hey, true. And that is true. Let's see. Let's see the podium. In third place, it's Maze. Hey, round of applause for Maze. Second place, Augustina. And first place, who is it? Drum roll. Osmo! Woo! Good job. Good job. All right, Bryce. And then the runner-ups. Excellent. All right. Osmo, great work. Where is Osmo? I've got to see the face of this person who is totally killing it. Is Osmo's camera on? No? Is it? No, it's not. Wah wah. All right. That's okay. Can you go back to the previous slide, Bryce? Thank you. Okay, so on the bottom left-hand corner, here's my real question to you. Thank you. Bryce put in the chat here, hydrogen. But Bryce, are you a science teacher? You just knew that? It said primarily oxygen. That was inaccurate. That's what made it false. It was a trick. Which dimension of the NGSS do these types of questions emphasize? The types of questions, put in the chat really quick. Hurry, everybody, in the chat. Which dimension of NGSS did that game really help us to emphasize? Was it the SEPs, the DCI, or the CCCs? SCPs, DCI, or CCCs. Hurry, 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 hurry. Oh, it looks like everybody's getting this one correct. The correct answer, Donna said science. That's right, Donna. You were absolutely correct. Oh, maybe it was just a typo because D is next to S. That's funny. I never realized that. Okay, anyways, yes, it's the DCI, so the disciplinary core ideas. And the point of this game is that was really kind of fun, but what happens if you didn't know the answers to all those? Does that mean that you aren't a scientist? Like there's something happening with your scientific thinking? What if you didn't know the age of the Earth? What could we do? What could we do? Somebody unmute. Talk to me here. Sometimes that happens when I'm on these Zoom calls. I get lonely. I want people to talk to me. Edna, you talked to me before. If I didn't know the answers to these questions, what does that mean about me as a scientist? What does that mean? Something? What do you think?
You have more to learn.
You have more to learn, but how would I learn that stuff? Edna, what do you think?
She's muted.
I know. I see her. It looks like she's trying to unmute a little bit.
Yeah.
There you are. Okay, Edna, what do you think? What could I do if I didn't know the answers to those questions?
Regarding the Earth hydrosphere?
Yeah, the hydrosphere. If I didn't know the answer to how old the Earth was, what could I do?
Google it.
Yes, definitely.
Exactly. I could just Google it. And guess what? That's what the state of California said too. The state of California says if we keep emphasizing these random DCI, what's going to happen is that all of that knowledge is going to be almost like useless to just have it sitting in there. We have to know what to do with that information after we have.
We lost your sound, Juanita. Juanita, we lost your sound.
Is my internet connection unstable?
Yeah, now I can hear you, but we lost the last little bit.
Oh, sorry. My internet.
And it was wonderful too, I'm sure.
Oh, man. All I was saying was that the state of California said that same thing, that it's very easy for people to just Google that information. So the real science teaching and learning happens with figuring out what to do with the Googled information. Am I still like unstable, psychedelic?
You're good.
I'm good? Okay, Bryce, can we go to the next slide? All right. So how are we acquiring information these days? Most of the information that we're acquiring comes from some kind of an internet source, right? And hopefully it's not coming from a super passive source where we're just hearing it, but that we're actually reading it. And so this idea of literacy becomes so important because literacy is access to this information. If you're not literate, you don't have access to this information. And a lot of people are, on the surface level literate, but when it comes to really reading and understanding, they struggle. So whose job is that to teach? We can say, oh, that's the English teacher's job, but truthfully, it's everybody's job. And so literacy in science becomes hugely important. We want to emphasize reading strategies like close and critical reading. This is a strategy that's highlighted in the Common Core State Standards in the framework for English language arts in the content area. So literacy in the content areas. And we're going to do a strategy called drop-in reading. So everybody has been muted. We're going to try this. We're going to try and unmute. We're going to try and do a strategy called drop-in. So if you see a word that's in red, I want you to say that word and I'll read the words in black. Can we try it together? I don't know if it's going to work, but I'm optimistic. Okay, everybody unmute. Unmute. If you're muted, unmute yourself. This is your one opportunity to come off of mute. Ready? Okay, we're going to try and read it. Close. Go ahead.
Close and critical reading, or CCR,
as it's known by our teachers, students, and parents, is a
Careful, purposeful reading
of a text.
It's teaching kids
How to really read.
rather than
Search and find.
for answers to basic low-level questions. It is
Designed.
to help students learn to do the
Higher
Higher
level
level thinking.
of
analysis,
Synthesis,
synthesis,
and
evaluation.
hey, you guys did it. I'm so proud of you. Excellent. You can mute again because I know how comfortable that mute is. All right. So when we're thinking about close and critical reading, we're actually thinking about 4 critical questions. The first question is, what does the text say? I know that's like, so it seems like duh, we're thinking about what does the text say, but this is actually revolutionary with kids. We actually post these questions in the classroom. We ask them to think about them. We tell them that the reading that they're going to do is a little bit complicated, and it's okay for us to read and then reread the text. What does the text say? That's the first thing. The second thing is, how does the text say it? So for that, we're talking about text structure, which becomes super important in science, because even when you're doing these search and find things, you'll find that a lot of our students don't come with the basic skills to even search and find. That first run through of text is just a skimming of information. The second run through is really thinking about looking for important information, how the text is structured. Are there subtitles, which happens a lot? Are there bolded words? What does that look like? The third is, why does the author say it? In other words, what else can you infer about the subject based on what is written? That's hugely important too. That's the text to self or text to text connections that we teach students, or at least their English teachers if you're in the secondary schools or teaching students. And then the fourth one is, what connections can be made? So we're reading this information. Why are we reading this? How is this helping me? What am I trying to figure out? If you want to know more about close and critical reading, there is an article that's linked at the bottom of this slide that you can peruse at your convenience. Next slide, please. We're going to practice close and critical reading along with a mechanism for really expressing information. So when you're thinking about literacy and you're thinking about thinking just in general, when you're taking in information in the most passive way, so there are 2 ways to take information if you're talking about literacy. One of them is listening and the other one is reading. Those are both taking in. So if you're thinking about breathing, that would be the inhale of information. The exhale of information is speaking and then writing. So in middle school and in high school, where you would expect to see this curriculum being taught, we want students to be reading complex text. We also want them to process that complex text via talking about the text with somebody else and being able to convey information about that text via writing. If a student is not able to write something, then that means that they didn't understand it in the first place. Okay, we're going to try our drop-in strategy one more time. So everybody unmute. I know I'm trying to just mute, unmute, just keeping you awake out there. That's all good. Unmute. Excellent. We're going to do the drop-in reading one more time. Are you ready? Okay, go ahead. Claim.
Claim, evidence, reasoning, CER,
Is a
writing strategy
that can
Develop
a student's
analytical thinking,
thinking,
and
argumentative writing skills.
skills.
to turn that I don't know into aha, so that's why we get those results in the lab, right? So we really want them to, you can mute again if you want to, just because it's feeling comfortable, and it gives your hand something to do while you're listening to me, so it's a bonus. It gives the students the opportunity to really process information. So CER, claim, evidence, reasoning, that's the acronym. A claim is just a statement that sometimes if you've asked a question, it answers the question. If you haven't asked the question, then the claim is just saying what I believe to be true. This is almost like my conclusion sentence. This is what I believe to be true. The evidence is whatever data that I'm using in order to support the claim, and that can be both qualitative or quantitative, right? In regular science classes, so I was thinking about my own science classes, the lab reports, this is really where I'm asking students to pull in that numerical data from whatever lab it is that we have conducted, but also those observational pieces, that's the qualitative piece. And the reasoning is the why and how. So how does this data support my conclusion statement of what I say is true or accurate? If you want to know more about claim, evidence, reasoning, because we're not going to spend tons of time talking about that, again, at the bottom of the slide, there's a link to an article that'll tell you a little bit more about CER. So let's practice those two skills with an activity that comes out of a repository of resources that goes along with these classes. So what we're going to talk about next, can you just go forward, Bryce? I think it's forward. Maybe it's not. Oh, yeah, it is. Okay. We're going to talk a little bit about the nature of science. Remember, science being a human endeavor. And we're going to think about that human endeavor as we're talking about the origins of the hydrosphere. When we talk about the origins of the hydrosphere, there is, and now I'm going to share, Bryce, so I'm going to ask you to just stop sharing, or I'm going to kick you out of the share here. And I'm going to come over here to my applications, hopefully, and hopefully all of this is going to work. And so if it doesn't, bear with me. But here we are. So the resource looks like this. The first thing is that there was an excerpt that was taken for a guide for assessing sources. So it's this recognition that whenever a student is reading anything, we want them to keep their science brain on. And what that means is that we really want them to start asking questions about confidence. How confident am I that this resource, whatever this resource is, I don't know if I'm actually doing something wrong. I feel like I am. How confident am I that this resource that I've pulled up is accurate, it's credible, it's valid, right? And especially when we're talking about the internet, because just because it's on the internet doesn't mean that it's true. So we want to talk to the kids about authority. You know, what authority does this person have? What kind of resource is this? Is this a blog? Is this a magazine journal? Is it a news source? Is it on television? How accurate and how objective do you think that it is? And all that relates to the confidence that I have in this as a particular source. Just really quickly as a conversation topic.
We lost you, Juanita. Can't hear you, Juanita.
Juanita, the last words we heard were conversation topic.
Juanita.
Can you hear me now?
Yes.
Ah!
The last words we heard were conversation topic. Am I correct, you guys?
Yes. Good job, Clover.
Thank you for keeping me honest over here, Clover. Okay, so we're going to have a conversation.
Are you
really
sure
quickly.
you're not doing that on purpose, though, Juanita? Because, you know, the suspense is killing us.
I know. Well, you know, it works in our favor. You got to take what you can get.
See if we're paying attention.
That's right.
Uh-huh.
So the conversation is really, why do you think that is an important conversation to have in a science class about accuracy and reliability of validity of resources that you would find on the internet?
Well, I, for one, my grandson is a big fan of asking Google and Alexa and all of those other ones. And then also looking online for things. And sometimes I have to show him this was an idiot in another state that says high school was not for him, so he quit. Is that what you want as a resource? I said, because as a 14-year-old, you've got the idiocy thing so down. I said, so, you know, you and I both need to gather.
You told him that? You said, you've got that idiot down real good already.
Yeah,
you don't
we
need
got
to.
that. And I told him, I said, and sometimes your grandmother does too. I said, sometimes I catch it too. I said, so we've got to be careful who we believe as far as what they've said. And I said, and as you read more, you will find conflicting resources that dispute each other. And you have to start looking for some ways to see which one is most likely right. I have to do that as an adult when I read things. So, you know, I don't know how much of that he believed or if he just blew me off, but at least he got that info that day.
That's right. And we just got to keep saying it out loud for those kiddos. Thank you so much for sharing that, Clover. Patricia also said in the chat, because there's so much junk out there. And that is very, very true. Edna said, determining the domain name will help us check the legitimacy of the information. Excellent. The kids need to know all these strategies. Just because it's on TikTok doesn't make it accurate. And so that is the science instructions. So when people start saying, oh, hey, you know, what am I teaching science right now? You're definitely teaching science when you teach those skills. You're teaching the nature of science, and you're also teaching those environmental principles and concepts. Patricia said there are really good resources at PBS that help teach fact checking. And what are good resources? Thank you for bringing that up, Patricia. If you look at the top of the page that I just shared with you, or maybe you can't see it anymore because I stopped sharing my screen, but that is where that, when it said an excerpt, it was an excerpt from those materials. Yeah, we definitely agree with that. So what we're going to do now is we are going to give you a chance to dive into some content as if you were a student, and you're going to do that via a Jamboard. We're going to put you in some small groups so that you can unmute a little bit. That unmuting, you are on the slide that I'm going to share with you, or actually the activity page. Let's see if I can do this. Maybe I can just do two things at once. I don't know. Let's try it out. I'm going to share my screen. And I'm going to come over here. I'm going to share this resource with you. And so it's going to be in the chat. When you get to the chat, there are 3 articles. Okay, you can click the links at the top of the page in order to get to the article directly if you want to. Or Article 1 and Article 2, just like, I don't know, full disclosure, Article 2 came from Smithsonian Magazine, and there was an image at the top of the article that I wasn't sure if everybody was going to appreciate. So that's why I copied and pasted the text, but you're more than welcome to go to those links to see it directly. There's also a Jamboard. The Jamboard is the resource. It's a graphic organizer that goes to... it's a link that goes to this graphic organizer. So the name of the resource, the internet source, and then science claim and supporting evidence so that we can practice this out. If you haven't used a Jamboard before, can everybody see my screen? Do you see where it says MWD, Close and Critical Reading? Okay, if you haven't used a Jamboard before, when you get to the site, at the top of the page, there are going to be, you're going to land on the landing page. And then depending on what group you're in, you're going to go to that slide. So if you're in group 1, group 2, group 3, group 4, etc., just like we did earlier today with Dr. Steele. When you're on your slide, you're going to toggle back and forth between the article that you read, the title, and the graphic organizer. Here, you're going to be able to take a sticky note, and then you can type whatever you want into the sticky note, right? And when you click save, that sticky note will auto-populate on the slide that you're on, and then you can just move that bad boy around, and you can also size it differently if you wanted to size it a little bit differently. I'm going to give you the link in the chat feature right now, so I'm going to stop sharing so that I can go back to seeing you guys. And is my internet frozen? No? Good. Okay, I'm doing pretty good then. There is, oh, wait, did I send that? Oh, no, I direct messaged it to just Bryce. Boo. Sorry about that. Here we go. Let me send it to everybody now. Does everybody see the link? Before we go off into our breakout rooms, can somebody, anybody, unmute and tell me what we're doing when we go into our breakout rooms? This is my teacher, check for understanding. Donna, you're not muted. Can you tell me what we're gonna do?
We're gonna read an article and then go into breakout rooms and answer the questions on the Jamboard.
Excellent work, Donna. You win the prize, the gold star right there. Virtual, of course. So you're going to be pushed out into the breakout rooms actually first. And then there are 3 articles, and you're going to try and glean whatever information you can about the origins of the hydrosphere. I'm going to give you, because there's 3 articles, what do you think, Bryce? Like 6 minutes? 2 minutes per article? Kathleen is looking at me with these big eyes. Is 6 minutes not enough time? 8 minutes? You think 8? You going to try 8?
8 minutes. And then wait a minute. Wait, I have a question.
Okay.
So they have 8 minutes to read it, or 8 minutes to read it and do the graphic organizer?
Read and do the graphic organizer,
Holy
because
moly.
I have so much
faith in me.
I have so much faith in these people. You have no idea. We'll start with 8. When we come back, if everybody's like, "Whoa, I'm blown out of the water," then we'll give you some more time. How does that sound?
We can always
That
check
sounds
in
fair?
with the groups. Yeah.
Totally. Let's start with 8 and then talk it over with your group. That's why you're in the small groups. Talk it out. Dennis, you have a question? You're unmuted. I like to. Good, you're good. I like to see you unmuted, my friend. Looks good on you. The unmute. All right, Bryce, you putting them in breakout groups? Excellent.
Well, I see just about everybody, but I do not see Juanita. Maybe she left town. That would not be good. We need Juanita.
Hey, I got kicked off.
Oh, but you're back.
But I'm back now. It's all about the excitement. Here we go. How does everybody feel? Do we need some more time? It looked like people were populating, but maybe we needed a few more minutes. What are we thinking, guys?
I could have used a little bit more time, but it was okay, Juanita.
Oh, it was okay. Okay, so let's talk for just a second about the articles. So, what were the articles trying to convey? Just some of the big ideas. We can go back to the I can go back to the Jamboard really quickly, and let me just share what you guys said in these Jamboards. Here we go. And I will start with group 1. Group 1, you guys were killing it. Look at all that data that you have to support your ideas here. So that water was on the Earth 4.6 billion years ago. They think that it was formed here rather than being deposited by comets and asteroids after formation. And they used a lot of evidence, but one of the pieces of evidence that they used was the carbonaceous chondrites. That's why they're saying that the water was already present, while the author is suggesting that water may have already been here, that other forms might have just added more water. And that was from National Geographic. From Smithsonian Magazine, it talked a little bit about what would have happened, or the implications of surface water evaporating and drifting back into space. The idea that comets and asteroids contain a lot of ice, and that by colliding with Earth, they added the same amount of material that could have delivered oceans worth of water to the planet. And then they were looking at different ratios, etc. And then the Encyclopedia Britannica thing, they were just starting there about how water arrived and accumulated on the Earth. So there were some differing ideas. Is that normal of science, or what do you guys think?
I don't see the little hand up thing, so my virtual hand is up.
Okay, go ahead.
Yes, I think and I think that this is important too, and maybe I kind of forgot about it in the back of my brain, but it's important that if they're going to do this research and they get differing differing, I don't want to say opinions because I think that cheapens the research, but
Arguments. That's the term that we're
arguments,
using.
there we go.
Scientific
If
arguments.
they get differing arguments from verifiable, solid sources, it lets you know that science is always a work in progress as well as proven fact.
Excellent.
And it opens discussion.
I love this conversation. Anybody want to add on to what Clover was saying?
Yeah, so I was going to say that it's a great way of showing them that, there's always, you don't just take one view and make it that solid view in your head. You have to be open to other evidence that comes along and make the students understand that they're always looking for more evidence. If it's not a scientific law and already, then they have to keep looking for evidence to show what other options there are.
Excellent. Thank you. Who was that?
Patricia.
Patricia, thank you so much for sharing. Yes, definitely. One more thought. Anybody else want to unmute and share?
Wait time. This is wait time, folks. It's so painful, isn't it? We're gonna call. Juanita's gonna call on somebody then.
I totally am. And I saw David. He wanted to say something because he unmuted. Then he muted again. David, what do you think? Just weigh in on the issue.
Well, just the fact that the different articles kind of pointed out different theories of how that water got here. And all of them actually did cite evidence to support their theory.
Excellent, excellent. And so the citing of the evidence, which was what made all of the claims somewhat reasonable, right? And why is it that there's no like definite answer? What are we talking about? We're in science class. Where are the facts that go along with this? Why is it that these are arguments, scientific arguments?
Nobody was there.
Nobody was there, as in so much of of our shared history. Nobody was there. And so we are gathering, the observable phenomena that we can find, like those carboniferous chondrites. We are using the information that we think we understand about the universe, and we are making a claim. And that claim will change, and it will continue to change over time. I think this is the biggest thing. If we could teach them one thing, is that science is not a belief system. Even things that we call scientific laws, there are still tons and tons of scientists who their whole job is to try and disprove those things. Because if we can find one example where it disproves that law, even though we found lots, millions and hundreds of thousands of times where it's worked, then it's still reason for us to keep questioning. And science is all about that questioning piece. That's the biggest thing here. So when we are in this class, what you'll find in the resource folder is you'll find resources where there's lots of things for students to read. But after each read, we ask about our confidence. How confident are we in this claim based on the data that we've collected so far? That should be the language. That should be our normal vernacular. Okay, so how confident are we about this claim based on the evidence that we've collected so far? And then we go out and we collect more evidence. That's really acting like a scientist and being a scientist. Bryce, do you think you can show the PowerPoint one more time, please? Thanks. All right. So here's an example. That was an example of a reading literacy activity that you would find in the folder that goes along with this. What you'll find is that the disciplinary core idea, or the idea of the origins of the hydrosphere, which relate to these water classes or relate to water just in general, that is the context of the lesson. But the lesson itself is using that phenomena to really work on that analytical thinking and that argumentative writing and and conversation as well. And that's what we want students to do. That is NGSS. When you're doing that, you're doing NGSS. You're teaching them the science that you're supposed to be teaching them. Next slide. And if you hadn't used Jamboard before, I'm hoping that Jamboard use was kind of cool too. So the next thing that you'll find inside, Dr. Steele.
Oh, no, I'm sorry. Are we moving on? I thought we were, what are we doing here? I'm sorry.
So the next thing that we're doing, thank you for asking that, Dr. Steele. we're going to move on now. And we're going to talk about another science and engineering practice that is so important, and that is developing and using models. So we're going to use that drop-in reading strategy one more time. I actually think this is the last time, so don't get too annoyed with it already. If you can unmute with me, we'll talk for just a second about modeling experiences. Okay, so on the red, go ahead and read that for me.
Modeling
experiences.
In 9 through 12, ask students to
Use
synthesize,
develop models
to
predict,
and
show relationships
relationships
among
among
variables
variables
between systems.
between systems.
and their
Components.
in the
Natural
and
design
Design
world.
world.
oh, when I see designed worlds, it really makes me think of Edna, because I was talking to Edna and I think she teaches an engineering class. And so all of these ideas that are true of, of science, the difference between science and engineering is science is really the human endeavor to understand the observable universe, whereas engineering is really the task of taking that understanding and making it and using it to do something useful for society, right? And so as we're going through and we're talking about models is a science and engineering practice, just like the literacy or gathering information was a science and engineering practice. And this is kind of a new one for a lot of us. So when we think about modeling, a lot of times people always bring up the science fair for me. And for whatever reason, that really doesn't do it for me. As far as a model. Models allow us to better understand or better communicate about systems. So what are the system's boundaries? What are the components of the systems? How do we use that understanding in order to predict what might happen in the future? And NSTA, somebody was talking about the National Science Teachers Association a while ago, along with the Science Foundation. We're working on really creating these observable features that you would see in a high school science class when dealing with developing and using models. We definitely want to emphasize for students that every single model has its merits and it also has its limitations. There is no model that's going to, show all of the different variables. There's no model that is going to predict things perfectly, and that goes back to that nature of science thing. So to be able to evaluate the merits and limitations of a model as a tool is the task of teaching in high school science. To design a test, to determine reliability, predict relationships, talk about those system components like we talked about, mechanistic accounts, and predict phenomena that are moving flexibly between model types, and figure out how to use complex models in order to do like virtual manipulations or virtual testing of things that we can't actually test in real life. So if you want to know more about developing and using models, again, there's a link for the NGSS NSTA page, because this is hugely important. And when we think about the California Science Test, these are the two science and engineering practices that you will find the most test questions aligned to: gathering information, communicating about that information, and then developing and using models. So we're going to practice using a model here, and the model that we are going to use has to do with something that we were talking about earlier. So the phenomena that we're going to explore quickly is the phenomena of aquifers. So should I do this, or the question is, will there be enough fresh water in a certain particular area, and what are the different variables that go into determining whether there would be enough fresh water? So what I'm going to do, so you can stop sharing now, Bryce. I'm going to share my screen. Oh, wait, before we do that, I am actually going to have to put the link inside the chat feature of the Zoom. So here we go. Here's the model. We're going to play with a simulation. So I don't know how many simulations you've used in your classrooms, but they're really kind of fun. We're going to explore how water moves both above and below Earth's surface, and where is the best place to access water. So inside the chat, you should see a link to the Concord Consortium and their simulation. I'm going to share my screen just so that you see what you would see if you're still there with me in the Zoom. So At the top of the screen, you should see something that says exploring groundwater movement. And so when you're there, you can unmute and give me like a, hey, I'm here. And you'll see that there's lots of different variables. This is okay. Excellent. Thank you. Thank you. I got a 1.
I'm there. One.
All right. Hey, that's my amen corner. I'm there. Okay, you're with me. Excellent. Thank you for unmuting. Okay, so when you get there, you should see just a big blank blue screen here. We're going to take on the bottom, on the left-hand side, you should see a field that says template and a drop-down menu. So a triangle, a downward-facing triangle. You're going to click on that triangle and you're going to go to what makes a good aquifer, number 1. When you click that, then the blue screen will now populate with an image, and that image is different colors. Somebody tell me, just go ahead and do just a quick exploration of this on your own. We'll make sense of this model together. Can you figure out what those colors mean on the screen? So everybody should be, what makes a good aquifer, number 1. And then how do we figure out what those colors mean? There's different, I don't know, designs, I guess. What does that mean? What is that trying to tell me?
The flow of the water.
Okay, excellent. How'd you find that out?
I clicked on that little arrow and it said pink is easy flow.
Okay, so, oh, excellent. So you found a field that said add layers, and there was a gray triangle. When you click that gray triangle, you got a box that popped up, and the different colors represented different what is it representing? Is there a word on there that might be unfamiliar to some of us? What is that representing?
Permeability.
Thank you. It's representing permeability. Excellent. Yeah. So when I say permeability to you, what does that mean? Like, what is permeability? I don't know, but I do see some clues right here with these colors. It says easy flow, and then at the bottom it says no flow. And I know that we're talking about groundwater movement. So what do you think is flowing? Anybody?
Water.
Water. Okay, permeability. If I had to define permeability, then how would you define it? Permeability.
Water flows.
How quickly or how easily water flows through that's not a complete thought. Flows. How would
Through specific strata?
Oh, through specific strata, through soil, through a substance. Could I say through a substance? So if I was going to define permeability, I would say permeability is the ease of flow through a substance. Let's just say, I like that term strata. What made you think of that term strata? Who was that?
It was Clover, your geography nerd.
Oh, Clover, our geography nerd for all of our nerding pleasure. Excellent. Yeah, so I'm into that. Yeah, definitely. So yeah, so all the different strata. So Clover, tell us what strata are. How would you define strata?
Really, they're just a scientific word for layers, because heaven forbid a scientist just say layers.
Excellent. And actually, it's an expert term, and we always love using expert term. And on this simulation itself, there is, when you're looking at the box that popped up with the word permeability, if we'd look to the left, that's what it says, add layers. So it could have said add strata, but we're going to make some sense of that. We could also add a well. We can add some water. We could remove features. Right now, I just want you to play with it. Make it rain. And then in order to do that, you add your water and then you just click the play button. So there's an icon that looks like the universal play button. It's that triangle. See what happens when you click that play button, everybody. What's happening? What's happening? What happens in the simulation?
It's raining.
It's raining. Oh my goodness. Everybody's getting so wet. And what is being modeled in our diagram here?
Permeability.
How did you know that it was raining? What was actually physically happening?
The little blue water drops in the alleged sky on the diagram.
Ah.
I'm too excited for a small chart.
Excellent. Actually, you see these little droplets coming down from the sky. We're going to assume that that's rain. And then what is happening with the rain? What's happening with the rain?
Collecting in the aquifer.
It's collecting somewhere. We don't know where it's collecting yet, but it's definitely collecting. What do you notice about the different layers? Do you notice it traveling what do you notice about that? What is this model trying to show us? What is it modeling?
Well, the water's running off the non-permeable layer.
Okay, so the water's running off the non-permeable layer and it's collecting someplace. Did anybody add a well? Do you see the chart? What is the chart? What are those graphs showing us? You see the graphs at the bottom right?
Flowback and a non-flowback well.
Interesting. Okay, did you zoom in where it said water level? You see the graphs?
I do see that.
Yeah, just play around with that a little bit. Oh, let's see. We're at a well somewhere and see what happens to our model. I'm going to add my well right. I guess I'm going to add it here. Okay. And then I'm going to press play again, see what happens. Oh, my well really isn't, I don't have any output yet. I have 0 output with my well.
Had you done your research, you probably wouldn't have put your well there.
I probably wouldn't have, but you know, I was just playing around.
Your well kind of sucks, Juanita.
My well totally sucks. Are you guys playing too? I'm going to stop sharing so that you guys can play. So you guys use your own simulation. See if you can find a better place for your well. Go ahead. I'm going to stop talking. You guys can talk through it though if you want to, because my well was totally, you were right. It totally sucked where I put my well. What are you owing?
I just learned how to dig my well deeper on accident.
Oh, hey.
Because that's why your well was sucky, because it only went down into the sand. I didn't call it sucky. Somebody else said that.
Well, you didn't want to hurt my feelings by calling my well sucky. It's okay.
No,
I'm not emotionally invested in my well. It's okay.
I'm this delicate, obnoxious flower, so you know, I don't know what to say.
Excellent.
I'm trying to remove the well.
Uh-oh.
Well, because I realized that I drilled into the granite instead of into the aquifer, so now I'm trying to get it off of there.
I see.
You can remove.
Yeah, there you go. Play around with it. There you go. You tell her.
I did. I hit. Oh, wait a minute. Let's see.
I'm going to add another well. What's wrong with drilling into the granite? You don't want to drill into the granite for your well? That's not a good well.
No. That's a waste of good, expensive equipment.
All right. Excellent. Let's see. I'm going to set a timer actually, or I don't know, Bryce, can you set a timer? Maybe I'll set a timer. We're going to play around with our simulation for 1 minute. Can we do it for
1 minute is better.
1 minute.
Right.
Un minuto más.
Un momento más, because we're a little behind for break, Juanita.
Right. And
Oh my gosh.
And before we go to break, I really would like, Juanita, if we could just debrief just real quickly the Jamboard activity, and then this one here with the models as to, you know, how they think their students would enjoy them and if they would use them.
Sure, yeah. 45 seconds to continue playing around.
Yeah, we'll just do that for a minute or two and then we'll go on break.
Timekeeping, 7 seconds left. 5, 4, 3, 2, 1. All right, let's come back together. There we go. Let's come back together really quickly. And like Dr. Steele was saying, oh, where am I? Where am I? I don't know where I am. Here I am. Here I am.
We can hear you.
I'm here. Okay. So here we go. So like Dr. Steele was saying, let's start here. If I was, just for the sake of time, I'm going to wrap this one up very quickly, but if I were doing this with students, some questions I might ask might be something like, where is the best place to access the water? Why do you think water pools or flows through certain things well, or not as well? What would happen if the water level reached the top of the Black Basin? How can water move through rocks that look solid? How does the size and shape of pore space affect the permeability of different sediments? Those are some of the questions that I might ask. And maybe you had some questions that you might ask too. In the classroom, we might do an example. In fact, we do an example, both an in-person example of an aquifer where we pull up aquifers with little pipettes and we build them in little cups. But this is a great way of expanding that, which is doing something that we wouldn't normally be able to do. In the last couple of seconds here, let's hear from you guys about the first two activities, like Dr. Steele said. Dr. Steele, I do believe that you teach a class at Cal State San Bernardino, which is the methods class. Maybe you want to talk about the debrief, because you had some great questions that they just came up, they just rolled off your tongue so easily. You go ahead.
Maybe not. But part of what I do in my university classes is we're teaching young people who want to be teachers how to be effective teachers. And so this whole debrief is really an important part of what we do. So thinking back, let's just look at the Jamboard example and activity. And we're only going to talk about it for just 2 minutes, I think, because we all want a cup of coffee. Being able to, let's talk about that particular activity. When we had students read an article or read those 3 articles and then utilize a Jamboard, or if it was an in-person class, you may have posters up and groups did something on a graphic organizer. First of all, have you used an activity like that in your classroom before? Thank you for that, Bryce or Juanita. An activity like this, or is this something new to you?
I've used one with looking at the evolution of adaptation, evolution theories. There's a really good one about bunnies and how different phenotypes survive better. So sort of a natural selection one.
Okay.
Really fun.
And how did your kids respond? Did they respond well?
Yeah, they really liked it.
Excellent. I think the benefits of the Jamboard are just group accountability, larger group accountability for sure.
Oh, I thought you were talking about the animation. I'm sorry.
Okay, the simulation. Excellent.
Simulation, yeah.
But having students read and then thinking about how do we support students that may have English learners that may not be able to read at a certain level. So what do we, how do we build those scaffolding in there? But
thank you for bringing that up, Dr. Steele, because actually that's where these 3 resources came up. And I was going to mention that earlier and I forgot. So if you looked at the 3 different articles, I think on top of the idea that they were making slightly different claims, the other idea was that one of the articles was really kind of easier to access. The National Geographic article was a little bit easier to access. The Smithsonian article, the Lexile level, which is the readability, was a little bit higher. And if you got to the Encyclopedia Britannica article, that one was actually probably the highest of the 3. So it really allowed for differentiation of information for your kiddos so that regardless of your reading level, you could have done it that way. The other thing is that you could have structured this activity so that maybe one of them was a video, multimedia, one of them was a video, one of them was an easy read article, and maybe one of them was a university level kind of peer-reviewed article idea, because that allows for students to access information in lots of different ways.
Right. Thank you for that, Juanita. And in the chat, somebody, Donna said, Jamboard's okay. I would use 1 article at a time for my ELs or what have you. So yeah, you don't have to use 3. You could use 2. 1 is fine. It just depends upon how you want to organize it. I think this particular one with 3 articles was to show you that there are differing
claims.
Arguments. Yeah. Thank you. That's all I wanted to say. Was
excellent. And the simulations. So thank you. I think that was that Patricia? Who was that shared about using the ecosystem simulation?
I can't hear.
Yes, that was
Is that Patricia? Excellent. Yeah, I think the other piece for us to remember with those simulations is that when we're talking about the California Science Test, the new versions of the science test, there's going to be so many simulations on that test, just outrageous numbers. So if you want to prepare your students for that, then you give them opportunities to really become familiar with those simulations in the classroom. I love how at the bottom there was the graph, and the graph allowed for both qualitative and quantitative pieces of information to be shared. All right. I think it's time for a break.
I think so too.
All right, everybody.
Allison, how much time do we have?
15. We're okay. We can still do a 15-minute break.
15-minute break. Okay.
So everybody comes back at 11:30, please.
Okay, we'll do that.
Well, welcome back from break. I'm glad to see everybody back. Alice, Dennis, Donna, David, I see your cameras are on. That always makes me excited. Today we end at 1 o'clock, so we only have a couple of more hours together. And there's a couple more activities that we would like to share with you. So, just as a review from right before break, we talked about 2 different ways to share some information. The first one was that close and critical reading. No worries, Patricia, I'm glad you're here. That close and critical reading, those strategies using the using graphic organizers, the graphic organizers in a digital setting, using Jamboard in order to do that, and then also using simulations. Even as we matriculate back into the classroom during after our post-COVID adventures or during COVID adventures, it's not post all the way. I think that you'll still find that those simulations are hugely helpful in preparing students for just the digital ask of the 21st century, entering into the 22nd century, whatever. We are going to talk a little bit about science and math connections now, because math is also another way of developing a model. It's one that we don't often think about, but it doesn't make it any less important. So, inside the folder, particularly for the water classes, in my district at least, we created something that was called a common investigation. Common investigation is exactly what it sounds like. It was an investigation, so it's like a lab that every single integrated science class did. Our lab had to do with floods and flood channels, and an actual flood channel project, a public works project that was happening in the city of Rialto. We worked with the city in order to get some of their planning documents, and then we created a common experience from those documents. So we're going to share some of those with you today. So Bryce, next slide, please. Hope everybody had a really good break. Okay, so Common Core math, I want to talk about how math has changed a little bit, just like science has changed. Math has changed a little bit too in the emphasis in instruction. I mean, obviously the math and the science is still the same, but where we emphasize our instruction is how things have shifted a little bit. In math, just like in science, they're really also emphasizing the use of context in order to make the math more relevant. In the new math framework, you'll see that a lot with something called data science. There's a brand new strand in that data science section. And here I wanted to talk about a practicing teacher that I just feel like has really good instructional strategies. If you've never heard of Dan Meyer, if you're not in that math space, Dan Meyer has something called a 3-act model. And the 3-act model kind of goes along with CPA, which is concrete, practicing, and then abstract. Hold on just a second. All right, sorry, young children in the background, if you're hearing peripheral noise. Okay, so the 3-act model really emphasizes a setup of some kind of actual real life context. Then you collect some data in order to solve a problem. And then in the 3rd act, you reveal what you discovered. So that's your claim. And then you reflect on how you figured out how to get there. Next slide. So this is our common investigation for the 9th grade. It's analyzing floods in a growing community and understanding human migration patterns and preparing for future flood events. So I want to go back to those environmental principles and concepts, which is this idea that human systems, human social systems interact with natural systems, and those natural overlaps, those relationships, that we can benefit from those relationships. We can help those, we can have a positive impact on those natural systems, or we can have a negative impact, or we can be neutral. In this particular activity, what we are trying to do is we are going to use a tool called Desmos in order to determine human migration patterns and think about how we can better prepare for large flood events. So if you're reading the context here, the climate models predict that as the global climate changes, it's likely that there will be larger and more frequent storms, which lead to larger flood events. And so we're thinking about this flood detention basin, but we need to figure out what the population of Rialto is most likely to look like in order to make the best model for the flood plan. So go ahead and click to the next slide. And so we actually found Rialto's actual population. So these numbers are not nice and easy, but the biggest part of this lesson is that this is a way for us to figure out why it is that we use mathematical models. So I heard somewhere, I think it was, who was in my group earlier? It was not Edna. Who was with me with Edna? Was it Kayleen? Asmal? It was someone. They were a chemistry teacher, and they were talking about trying to find that overlap. Here is one example of a time when the model that we're using isn't a simulation, it's a mathematical model, and this is why we would use it, okay? So what we're gonna do next is I'm gonna save these numbers. These numbers are gonna be really important, but I'm gonna teach you how to use a tool that your math teachers are already using. Anyways, they were talking about how it's hard to integrate content sometimes, and this is a great example of that. So I'm gonna ask you to stop sharing, Bryce, really quickly. And we're all going to go to a place called Desmos.com. Desmos.com. So hold on a second. Let me see. So here we are. Actually, I think I should probably just take you there from the search engine directly. So is everybody following along with me? Because I'm going to do 2 steps, and then I want you to do a couple of steps. Does that sound fair? I guess somebody's going to have to unmute because I can't hear you.
Yes, fine.
Yes, okay, perfect. That's what I like to hear. Okay, so I'm going to come to just the regular Google screen, and at the top of the screen, I'm just going to type in Desmos.com. And when I get to Desmos.com, it's going to take me to this lovely page. I don't need to log in. I don't need to set up anything, although I could have you do that if I was your actual teacher. But for the purposes of this example, we're just going to come right here to where it says Graphing Calculator. Then I'm actually going to ask for you to toggle back and forth with me. I'm going to do something, and then you're going to do something. The directions, however, if you wanted to take this actual activity back to your classroom, are actually physically written out. So I'm going to stop sharing for just a second, just so that I can see you. Did that make sense? You can give me a thumbs up. We're going to toggle now between 2 screens, this screen and a new tab. So everybody toggle to a brand new tab and go to Desmos.com. And when you end up to the Desmos calculator, then come back to this screen. And then Bryce, do you think you could show the presentation again on this screen and then go to the next slide? Next slide. Perfecto. Okay, bueno. All right. Is everybody at Desmos? Give me a woo woo if you're at Desmos. Oh, there it is. Woo woo. Okay, we're at Desmos. So now, if you're toggling back to this screen, you'll see that for the students, we actually laid out all of the directions exactly the way that we wanted them to do them. But we're going to talk through them, or we're going to work through them one piece at a time. I can tell you from practice, we've been doing this investigation for 3 years now, and everybody thought when we first initially made it that it was going to be too hard because of these directions that it was going to be too hard for the kids to do, because what we're doing is we're figuring out which mathematical model best represents a data set. And we can't ask ninth graders to do this. They'll never be able to do it. But because the directions are so clear cut, we have had success 100% of the time, even with the students that just, are not fully literate, who struggle in math, etc. Okay. So the first thing that we're going to do is we're going to click on the gray down pointing triangle next to the plus sign in the top left-hand corner. So when you click that, then you should get to a screen. Oops, sorry. Let me share my screen now. Híjole, where am I? I'm right here. Here I am. Sorry, I'm going to stop sharing. I'm going to stop your sharing. Okay, Bryce? Okay. Okay, top left-hand side of the screen, when I click that little arrow, then this popped up next to the 1. Now I'm going to click that plus sign, and when I click that plus sign, I'm going to go to table. Now, I'm going to put in the years each decade from 1920 to 2010 in my X column. 1920 to 2010. Whoops, sorry, 1920. And then while I'm doing from 1920 to 2010, I want you to toggle over to your Desmo screen and for you to do the same thing. All I did was press the plus sign and then table. And once I added that table, now in my X column, I'm just doing increments of 10 years from 1920 to 2010. All right. I'm going to toggle back over to where you are to see if I can see you. I'm going to do a countdown here. Give you 30 seconds or so. All right. If you're with me, give me a hey.
Hey.
Hey, Donna's with me. Bryce is with me. Hey, okay, here we are. Okay, so we've got our decades. Now I'm going to read you some numbers. Okay, are you ready? In 1920, your Y value is 961. 961. In 1930, it's 1642. In 1940, it's 1770.
Oh, gross.
Are we okay? Okay. You ready for 1950? 1950, 3156. 3156. 1960, 18567. 18567. 1970, we're at 28340.
Oh, no
Right.
comment.
You ready? 1980, we're at 37882. 1990, 72,791. 2000, 92,035. And 2010, 99,171. If you're with me, say, there it is.
Here it is.
Hey, there it is. Okay, there it is. So what you have here, excellent. There it is. What you have here is on your X values. Your X values are the year, and your Y values are the population of Rialto. The X values are the year, and the Y values are the population of Rialto. Now, when you click enter, what should happen is that this table is automatically populated, and it actually is automatically populated. But the issue is that there is something wrong with your domain and range. Your domain and range, you can't see that it's automatically populated. So in the top right-hand corner of your screen, you should see an icon that looks like a wrench. We're going to click that wrench icon, and we're going to look for x-axis and y-axis. Your x values are your domain. What are your x values? Your what?
Domain.
Your domain, very good. And your domain right now is set from -10 to x to +10. We're going to change those domain values so that the lowest domain value is 1900 and the largest domain value is 2050. 2050. 2050. What do you think that those domain go along with? The year or the population?
The year.
Year.
Very good. Yes, your X values are your year, so your domain is years. For your Y values, currently your range is set up to -6.246 to +6.246. We're going to change that to 0 to 150,000. 150,000. What did you see on your screen when you changed that value? What'd you see? On your screen, what do you see?
Points.
Hey, the points! The points magically appeared. Excellent. So does there appear, so now we're going to have a science conversation here. So we're going to make sense of this data. Does there appear to be a relationship between Rialto's population over time?
Yes.
Yes. Okay. So how do you know? What is that relationship? How do you know? Somebody said yes, and they were very confident, and I agree with you. How do we know that there's a relationship? What is the relationship?
As the year goes up, the population increases.
Very good. As the year goes up, the population increases. So in science, models are used to represent a system to aid the development of questions and explanations. And we generate data that can be used to help us make predictions and to communicate these ideas with others. So here it appears that there is a relationship between these numbers, but we want to figure out if we can use a mathematical model to determine whether there's a relationship or not. Now, we're in the 9th grade, which means that we're not just talking about linear relationships. It doesn't have to just look like a line. We could be talking about linear or non-linear relationships. What we need to do is we need to try out a few relationships and see if we can figure out which mathematical model best fits our data set. Can we try that? So we're going to compare 3 mathematical models, and we're going to utilize regression analysis to evaluate which model has the best predictive value. That sounds really, really hard, but I have all this faith in you, and I totally believe that we can do this. What are we going to use? We're going to use regression analysis. Can somebody tell me, what are we going to use?
Regression analysis.
That's right. We're going to use regression analysis to evaluate which mathematical model is the best predictive value. So on the left-hand side of the screen, we're going to start with the mathematical model that we've been using since the 6th grade, ladies and gentlemen, and that's the linear model. So right now, on the left-hand side of your screen, you're going to put your cursor right where it says a 2. Do you see the 2? Put your cursor right where it says the 2, and then I am going to give you the expression using the keystrokes. Like that means what keys we're actually pressing. So can we follow along together? We're going to press a Y and the number 1, and then we're going to use a tilde. The tilde is the little squiggly line. In order to get the tilde, you're going to click Shift, and the tilde key should be right underneath your escape key. So right above Shift, you should see the tilde. Y1 tilde MX1 plus B. Does this look familiar from your math class? Y equals MX plus B. When you clicked Y equals MX plus B, what do you see on your screen? What do you see on your screen? A line. Excellent. You see a line. So what about those dots? Are those dots exactly on the line?
Nope.
No, but they're around the line. Would you say that that kind of models what we're seeing? Would you agree? Yeah, it kind of models what we're seeing, but that would be a linear example. So now I'm going to come back over to the left-hand side, and underneath the number 2, you should see like a little circle that has like a sine function. It looks like a little wave. If I click that, the line goes away. Click it. Did you see your line? I can click it. The line shows up. Click it again. The line goes away. Everybody with me?
Yes.
Excellent. So now I'm going to go down to number 3. Inside the 3, I'm going to use those same keystrokes. I'm going to give you some keystrokes. Follow along with me. Y, 1, tilde. Everybody remember, you click the shift, go all the way up from the shift to that little squiggly line. Y, 1, tilde. A, X, 1. Then I'm going to do the caret. The caret, I'm going to press shift, and on my computer, it's above the number 6. It's the little triangle like that. It's called the caret that points up. Now I'm going to put in YX tilde 1 tilde caret 2. Thank you. Then I'm going to do my plus sign, which is the shift equal right next to my backspace key. BX 1 plus C. Does that look familiar? Y equals AX squared plus BX plus C. Do you remember that from 7th grade math? Yes, everybody remembers that from 7th grade math. That is a quadratic model. So here's my quadratic model. Does it look the same or different from my linear model?
Different.
It looks different. Now, does it look like any of my points are on this model? Does it fall? Do they fall on the line?
Much better.
Yeah, it does. It looks like some of the points actually fall on the line. If I go back to this 3 underneath that little squiggly line, again, I could turn that function on or off. I'm going to go back up to the 2. Look at this. I can turn both of them on at the same time. All right, excellent. Now I'm going to go down to where it says 4. I'm going to turn them both off. Now I'm down where it says 4. This is the last one. I told you it was going to be hard, but it's not that hard. We're all here with us together. Are we ready? Did we buy the 4? So now we're going to do an exponential model. So I'm going to do Y, 1, shift, tilde, A, B, caret, which is shift and the number 6, caret, parentheses, which is shift and above the 9, X, 1, parentheses, parentheses. Excellent. This is an exponential model. So we've looked at 3 models. We've looked at the linear, we've looked at quadratic, and we've looked at an exponential model. So now when you're looking at this model, is it the exact same or is it different than the other 2 models?
Different.
It's a little bit different. It's a little bit different. Do you think that the points, does it seem like there are more points on the line or less points on the line?
Less.
It looks like maybe less. I can't remember. So what I'm going to do is I'm going to come over here and I'm going to put all of the lines up together. And then I'm going to go one by one. Okay, so here are all my lines together. Which line, the red line, the black line, or the blue line, does it look like there are more points that fall on the line? Red, black, or blue? I don't know if they're red, black, and blue on yours too. So if they're not, if the colors are different, then I'm going to say the linear model, the quadratic model, or the exponential model. Which line looks like more lines fall, more points fall on the line? Let's do them one at a time. Let's look at this one. So on the line, how many points fall on the line? Does it look like any?
None.
None. Oh, it doesn't look like any. Okay, so let me turn this off. Let's see. Let's look at the the quadratic. How many points look like fall on the line?
5.
Maybe 5. Let's see. 1, 2, 3, 4. Maybe 4. I don't see the 5th one. Do you see?
It's 4.
Maybe 4. Okay.
Next to it.
Okay, let me turn that one off. Let's look at the exponential model. How many points fall on the line?
3. 1, 2, 3.
maybe 3 are pretty close to the line. So if you had to make a claim, what claim could we say that which model? The linear model,
Quadratic.
the quadratic model, or the exponential model? Which one? The linear, the quadratic, or the exponential? Put it in the chat. So let's toggle back to the Zoom now and put it in the chat. Which one do you think? The linear, the quadratic, or the exponential model? Linear, quadratic, or the exponential model? Linear, quadratic, or the exponential model? Ooh, look, there's some consensus here in our science community. It looks like the quadratic model is the mathematical model that would best be used to predict what the population may be like in the future. Excellent. Now I want to come back to the screen that I was just sharing really quickly. And I want to show you, we said we were going to use regression analysis. Did we use regression analysis? We did. We used an analog version of regression analysis. I want to show you this. As a consensus measure, we said that the quadratic was the best model. Now in regression analysis, the regression factor is R squared. Do you see R squared in our list over here underneath the word statistics?
Mm-hmm.
What do you notice about the R? What's the R squared value for the linear model? Somebody tell me, what's the R squared value?
0.9756.
In the linear model.
Sorry,
In the linear model, it's what?
0.8846.
Very good. 0.8846. What about in the quadratic model? What's the regression value?
0.97.
0.9756. And in the exponential model, what's the regression value?
0.9379.
So we said that the quadratic had the line that best fit our data set. If you were going to go by R squared values, what kind of claim could we make about the R squared value? The R squared value, if the points are close to the line, then the R squared value will be close to what number, 0 or 1?
1.
1.
It'll be whatever mathematical model that has an R squared value closest to 1. Closest to 1. So
0.9756.
yeah, 0.9756. So did our regression analysis confirm what we noticed just through our qualitative observations?
Yeah.
Yes, they did. Yes, they did. You guys are mathematical geniuses. Best you didn't know you were that good at math. Okay, so here we are. What you will see is that we're going to use this value now in order to determine what the population will be in 2020, 2030, and 2040 and 2050, right? So how am I going to do that? I'm going to slide up. So I'm going to click the line. Is everybody with me?
Yes.
Click the line, slide up. Somebody tell me, what is the population in 2020, you think, according to our model? Oh, what?
135,391.
Hey, okay, that's the prediction. What about 2040? Or 2030, I'm sorry.
2030 would be about 170.
Okay, so I'm going to zoom out just a little bit. And so if you click that minus sign, you can zoom out. What about 2040?
Wow.
200,000.
200,000. And what about 2050? I'm going to zoom out. I got to zoom out a little bit more. What about 2050? What's the population?
235,000.
235,583 people at the present rate of progress will be citizens of the tiny city of Rialto by 2050. Is there going to be enough water to support that? And what does the flood plan have to look like in order to support those pieces? That's the question that we pose to the kids using this. And what do you think? What do you think about that? Were we using some expert math vocabulary? Let's start there.
For sure.
Yeah.
For sure, we were using some expert math vocabulary. Was it too hard? Were you like, what? Quadratics, regression analysis? We're never going to be able to do that. Guess what? That is actually the science ask at the high school. Is anybody currently doing that level of science in their science classrooms? Not very many people, but that's how we're trying to up the ante just a little bit. All right, Bryce, can we go back to the PowerPoint? What I want to say about the Desmos tool as a tool just in general, and maybe if you're science teachers or CTE teachers, maybe you didn't know, but Desmos is the official tool that students can use on their math CASP test. It's also the tool that they can use on their ACT tests and their SAT tests. It's the tool that they can use on the AP exams. So when the science teachers also use that tool, it just helps the students better understand. Because we were talking about actual figures or actual like real things that kids could wrap their brain around, the numbers then meant something. It was important for us to find the most aligned mathematical model, because we were trying to figure out what the population was actually going to be like. So it was a good question of, does that sound reasonable? Is it not reasonable? I can tell you it's 2020 now, and we are over 100,000 people in Rialto, and well over 100,000, which is always interesting. All right, questions about this one, about the model, this model? Comments, concerns? Donna?
I just liked it. I just have to use it more to get more familiar with it, but no, I liked it.
Oh, excellent. Patricia, did you want to say something?
Oh, I was just going to say a similar thing. You know, it's just sort of, how am I going to integrate this in? I think this will work really, really well in my AP environmental.
For sure. And what I can tell you is the hardest part is really getting the kids to make the table the first time around. But if you set up yourself as a classroom teacher, then you can set up a classroom, and then the data can already be in there, and then you can just manipulate the data. Just using those three models, honestly, I feel like over and over again, those are the most common models. So the linear and nonlinear functions being the quadratic and the exponential, those ones are the most common ones that they'll see on all the tests and all that stuff. So just asking over and over which model would have the best predictive value. It also builds into that mathematical and computational thinking, which is another science and engineering practice. All right.
It'd be really good to use, there's lots of population math in environmental science, and it'd be a good way to have them graph it and check it to see if the model fits with the actual population math that they did.
Definitely. Just remember that Hardy-Weinberg equation for ecosystems, that's not in the regular science NGSS standards for ecosystems. It might still be in APES, AP environmental science, but in the regular NGSS standards, that there is an assessment boundary in the performance expectation that talks about ecosystems about that particular equation. All right. That being said, which features did we talk about when we were talking about modeling this morning? So you saw two different examples of models, one of them being modeling using a simulation, and some of the different features that you could highlight or questions that could be asked that are mostly related to that qualitative piece that goes along with, okay, what does this look like? What might this, again, going back to that predictive power, I think for the most part, that's the part that kids have the most difficulty with. Asmao, I saw that you got a little bit lost with the Desmos, but just play around with it. This is a great also like interdisciplinary opportunity for you to have a conversation with your math teacher colleagues. Just tell them, hey, I'm using Desmos in my class, and I hear that you guys are supposed to be using Desmos. Just a funny side story was that the science teachers made this lab. The math department was like, yes, we're using Desmos. My science teacher started talking to the math teachers like, hey, we're using Desmos and we're doing XYZ. And the math teachers were like, what? And then they had to kick up their game because they actually weren't really using it. They were telling people at the district that they were using it, but they weren't. And it came out in those PLC meetings, and it was really interesting. So, so that's just a funny side story. But which features did we use this morning? This morning, we were trying to illustrate relationships between systems and between components of systems. And we saw that both in the simulation as well as in the Desmos, the mathematical modeling. We talk about limitations? We didn't actually talk about limitations, but I think if we had more time, we definitely could have talked about limitations of both models. And did they help us to predict or solve a problem? What do you guys think?
Predict for sure.
Yeah, predicting power. Yay for predictive power. So just remembering that those two SCPs are hugely important, developing and using models, mathematical and computational thinking. That's actually 2. We talked about analyzing information, communicating about information. That's 2 more of your SCPs. So out of the 8, we talked about 4 and all using the context of water. The context of water. Floods, origins of water, aquifers, groundwater, all that good stuff. If you want to know more about those practices, again, that link is on the bottom of the slide for the NGSS at NSTA. Bryce, next slide, please. Now, the thing that makes this class a little bit different is that there's this idea of developing career connections. And the career connections also actually help to develop, experiences both in and outside of the classroom. Every school, I'm getting some feedback. Every school is close to somebody's water district. In our district, we have 2 water districts. And I just basically went and I asked the guys if I could do a really quick interview with them about water careers. When you go, if you're trying to develop a relationship with an external organization. So here you're working with MODOC, which is awesome. When you're developing relationships with these outside organizations, that I've determined, or in my work, is that typically what happens is we're speaking completely different languages. The industry person is speaking things in the way that it makes sense to them, and the school people, we're saying stuff that makes sense to us, and we're just talking right past each other. They don't care necessarily about our schedule, and we can only accommodate their schedule to a certain extent. So, so you need to really think about levels of engagement when you're talking to those outside organizations. And it's nice to have a little list, so to say, hey, I would really love to build a partnership with you, East Valley Water District, let's just say West Valley Water District.
Uh-oh, lost you, Juanita. Juanita. Can anybody else hear? Oh, yeah, she's stuck again. Thank you, Asma.
Sorry, am I back?
You're back.
Am I back again? Okay, so here's a nice little list of...
No, you're gone again. You're gone again, Juanita.
Can you hear?
Yeah,
am I stuck again?
No, we got
okay. Okay.
Don't move your head.
Oh, sorry. Okay. All right. I'm going to try not to. Anyways, here's a little interview from my friend Dayton, and also there's another guy in this video. It's Dayton and Allison. Help me out. Who's
Oscar? Is it Oscar?
No, it's not Oscar. His name Marlin. I'm like, he's named after a fish. Nemo.
Oh,
Marlin. So Dayton and Marlin talking about careers in water. So Bryce, can you play the video?
As mentioned before, stay in the state of California, Southern California being at that. There are going to be too many creative ways to come up with water, reusing water, renewable energy, turning biosolids into fertilizer, methane gas. There's just a lot of avenues that come from the water, wastewater, mainly the wastewater side of the house. So if people plan on staying as you get older, starting a family and staying in Southern California, you're going to pay close attention to water and wastewater. There's going to be different types of cogen systems where you're using methane gas to produce electricity, to power up facilities and so on and so forth. And who knows, maybe in the future it'll even get as big as, communities. I don't know, residential areas. But as of now, you just can't, we have too many people here and not enough water. We got to get more creative. We got to find ways to reuse water. So it's, I would say probably environmentally it might be in the forefront of everything, more important than anything else.
My path into the water industry kind of fell into my lap. I joined the Air Force in 2002. My original job that I signed up for was a crew chief. Then at the end of boot camp and all that, they were like, sorry, your tech school, which is your on-the-job type training, is backlogged for like 9 months. So do you want to get back out and go back home and come back 9 months later? I said, nope, I'm already here in Texas. If you let me go back home, I'm not coming back. So then they gave me a list of different jobs, and when I signed up for it, it was actually, it stated utility systems in general. And they're like, yeah, you get to work with electricity and, some water stuff. And I was like, okay, it sounds pretty cool. And when I found out more in depth on what it was, I was like, man, I don't really want to do this kind of stuff. Then went through it. Seemed very interesting. There's a lot of science, both chemistry and microbiology. The microbiology part of it is what kind of fascinated me the most. And went in with kind of, my guard up a little bit, but then as time went on, for me, this is just not a job. It's not just a paycheck. I actually enjoy what I do. On a day-to-day basis, there's always a challenge. No matter what, you're always going to be challenged. So if you're looking for a challenge or you want to challenge yourself, you're always going to learn in this industry, no matter how long you've been in it. Technology is always changing.
Well, I'm going to be a professional baseball player, but then they said I was too short, so no. I'm okay. No, okay. So my path into this industry, I fell into this industry. I didn't think anything about wastewater. I didn't think about anything after you flush the toilet, growing up. And I would just say, well, how good it's gone. I left our house, right? Or when I turned the water on to brush my teeth, there's water. That's all I knew about it. I had got out of the military and was looking to get into law enforcement. I had a friend in the industry who had a lead position, had a little bit of rank at this facility here, and kept trying to entice me to come over. And I kept saying, yeah, I'm not sure if I want to go and mess with sewer water. And he said, hey. So his main takes were, it's a great job, it pays great, you learn a lot on the job, and it's recession proof. I said, no matter how bad the economy gets, you will always have a job. And I said, okay, sign me up, I'm going. So I came down, I got in it for a job and fell in love with it. I saw that it is my career now, and there's something very rewarding about doing a service and returning it back to the community, whether it be somebody who lives in this city or even if you did it for a neighboring city, to know that you have, because people don't think about it every day. They just get up, brush their teeth, go to work, they grind out their job, and then they come home and use a restroom, and that's life. But to know that this industry made sure that, we made sure that water was cleaned properly, and we made sure that we returned it back to service properly, and then the guys who work on the freshwater side, drawing out from the wells, hey, we're going to make sure and treat that water. We want to make sure and get it to your pipes, and we want to make sure that you have perfect PSI, so when you turn your water on, there it is, magically. So, and it's a rewarding job. I love being part of an environmental job, having a job in the environmental industry.
State, you have to take a test, and there's certain grade levels. Right now, I'm currently a grade 3 operator in the state of California. I also am dual certified with the state of Arizona as well, so I hold licenses in Arizona and California. Right now, I did my grunt work. You always start off at the bottom and eventually work your way up. So technically, I've been in the industry since 2002. It's now 2016, so 14 years later. I'm now the operations supervisor. There's multiple paths you can do. Like I do wastewater. You can do freshwater side. There's the distribution lines that gets the potable water out to customers. And then there's a collection system. After you use the water and it goes down your drain, there's lines that actually bring it to our facility. So there's groups that handle that. One of the things, if you're really, really into science, you can get into laboratory, and like real analytical stuff. It just really depends on how far you want to take it. There's guys that have actually, like Dr. Ken Curry, he's got his PhD and he's written numerous books, and it really gets into like, we've got microorganisms that we refer to, most operators basically know, nitrification and denitrification, but then he'll break everything down. So it really just kind of depends on the individual, how much time you want to put into it, and how much you want to learn. I mean, I've been places where I've seen guys retire with just a grade 1 license, and then you've got, some guys that are probably even younger than me that are grade 5s now. It just really depends on the individual. So I'd say anyone that's looking to get into the industry, I'd say go for it. There's a lot of schools now, especially with the drought. A lot of schools, especially your junior colleges. I know Sacramento State has a program that's strictly water industry. So there's a really big push, and as we continue to grow as a society, we're going to start looking at different avenues of being sustainable when it comes to water.
Well, as of right now, it's gonna continue to get harder. I would encourage my own children and other young people to get some schooling under their belt. You can get your basics done, your sciences and all that stuff, but they also do have courses now at San Benito Valley has a course for wastewater technology. There's different junior colleges and I believe even 4-year colleges that have forms of that. You don't need a degree yet to get into the industry at entry level, but I would say over the next 15-20 years you just might. So to get a head start on that, to leapfrog and some of the other competition, maybe get right out of high school and go right into college. And even if you're not sure if college is for you, because college, I understand, it isn't always for everybody when they first jump out. Even knock out 2 years, get an associate's and get your sciences done will definitely help you get in the industry. And then once you get in the industry, climbing the ladder, it'll only help you to have a degree, even if it's a 2-year degree, a 4-year degree, definitely. We have a lot of engineers getting in the industry right now, for whatever reason, whether it be civil engineer or they're jumping into this industry, I think because they see really it's booming, the influx of all these wastewater facilities going up. I always say about 33 million people in the state, probably 28 million of them right here in Southern California. So there's going to be more wastewater industries popping up. There's going to be more booster stations and small plants and small, these new style of plants come with a small footprint. I mean, there's going to be creative ways across the board. And that's not even getting into biosolids plants that do just methane gas or renewable energy. And they're talking about using by 2019, 2020, taking food waste, actual food, that we scrape off our plate at Denny's, instead of it going into the trash and going into a landfill, going into a different bin and going to a facility that does biosolids. So it's a booming industry. It's an interesting industry, and I still stand by what Chip said a long time. It's a recession-proof industry. If you're in this industry, whether it be maintenance or lab or operator, or collections, distribution, you'll have a job, and you're gonna have a good job at that.
Hey, thank you for watching that video with me. It was a little bit long, but there was some really great conversation happening in the chat. As you were watching it, what were some of the things that stood out to you? I saw some things in the chat, but does anybody want to unmute and tell me what were some of the things that stood out? Go ahead, Donna. Yeah.
You don't have to have a 4-year degree to work for them. In fact, you can start entry level and then just get more schooling under your belt and move up the chain and take some tests.
There you go. You know what I think that's like a really important point, is because sometimes science in particular, I don't know how many science teachers are on the call, so I'm just going to assume. Science sometimes has the reputation of being an elitist subject. Like, oh, only the kids that are going to college really need to worry about science. You don't worry your pretty little head about it if you aren't really headed toward a four-year university. But that's not the case. Scientific literacy, environmental literacy is for every single student. It is an equity issue. And to disenfranchise a group of students by thinking that they have to go to some kind of a four-year institution post high school in order to be a part of the scientific community is really not doing the best for our kids. And I feel like we can do better. We can be stronger advocates for equity when it comes to scientific literacy, when it comes to environmental literacy, and when it comes to really having a conversation about jobs and the job market. Yeah. You want to add something else? Yeah, go ahead, Donna.
Department of Water and Power, coming from Los Angeles, there's only 3% of the women working there, and they are trying to hire as many females. I saw a comment in the chat. So if you have a female in mind that lives in the city limits of Los Angeles, and they can go and interview and possibly get hired right away.
Yeah, exactly. And when you're thinking about outreach for your classrooms, making sure that you bring in those female engineers and those female techs so that the kids see the techs of color, definitely. All those things are things to consider as you go back to your classroom. As you can see, a lot of the techs that I found in my particular region are ex-military, so veterans. All those things are really important, I think, for kids to see, just because representation matters. So along that line, so inside the class resources, you'll also see that there's a lot of activities, well, at least one or two activities every quarter or so that ask students to do some kind of research, whether it be certification in this field or talking to somebody that's in the field or reaching out to somebody that's in the field, because I think it's really important. It answers the why do I need to know this question. That kids always ask at that age. I mean, everybody asks that. Whenever I do anything, I ask that same question. Really, Dr. Steele, why do I need to do this? Why do I
Trust me.
All right. The last thing is that that I wanted to share today, and thank you guys for letting me share so much. The last thing I wanted to share inside the folder is this idea of graphic organizers that go along with the interactions between those natural and human social systems. So Bryce, can you put up the PowerPoint one more time and go ahead to the next there it is. Yeah, so this one is one that comes up over and over. It's devoid of really any specific activity, but there was one activity that I wanted to link it up with today, but is essentially, it's anytime you're using any phenomena, you can always come back to this question of how are natural and human social systems interacting in this particular scenario, and then what are some of the components and processes involved in that interaction, and what are the potential effects of those interactions on the school community. So again, I was having conversation earlier with Edna and someone else. I'm so sorry. I can't remember. It was Edna and Alice. I think it was Alice. Yeah, Edna and Alice. About just environmental literacy just in general, and the idea that the environmental community has done a great job at explaining to everyone why, climate change, all of the negative things that are impacting the planet. And what that has led to is there's an actual disorder, a childhood disorder called environmental anxiety. The kids are hearing all these things, but they're feeling like, oh my gosh, there's nothing for me to do about it. The whole world is just falling apart and I'm just stuck on this sinking ship. So for every 40 pieces of information that you give kids about environmental burden or environmental hardship, we need to give them 60 additional pieces of information about what it is that they can do so that they don't utilize what a lot of adults are utilizing right now, which is strategic avoidance. We know that something isn't good, but we feel like if we just close our eyes to that thing, it'll go away. Eventually, we won't have to worry about it anymore. It's okay. The mid-century projections aren't that great, but that's okay. I probably won't be here anyway. That's not a very nice thing to think on any front. So really talking about some of the things that they can do. So I wanted to link this up with a movie. It's a movie that we did put into one of the classes, and it's called Damnation. I was going to show a clip of it, but then I was like, well, I think maybe we can just show the trailer. So I gave Bryce the trailer. I would really strongly recommend it. It's not on Netflix. It's not on, Prime. You actually can purchase it through Vimeo. You can download it and purchase it through Vimeo. It's $10, but it's really good. Okay, go ahead. Play the trailer for us.
I don't think FDR ever saw a dam that he didn't think should be built. It just really seemed like a great idea coming out of the Great Depression.
Like all constructed things, dams have a finite lifetime. And a couple decades ago, it was radical in terms of thinking that you could take a dam out. It was unthinkable. Go back 50 years, it was legitimately crazy talk. The conversation's changed.
Taking a dam out and opening up a watershed, reconnecting it with the fish that were there for hundreds of thousands of years, it gives you, a hope.
You can take half of a salmon fishery, eat it, and they'll keep replacing themselves. What kind of a species throws that away?
We, as a country right now, are infatuated with tearing things down.
Some people seem to have forgotten that before the era of dam construction, the endless cycle of withering droughts and violent floods constantly plagued our watersheds.
You're asking some nasty questions when you ask about a free-flowing Snake River. It'd be a lot of teardrops of joy to see that river running again.
There's a great good here that belongs to the American people that's being stolen by a very small, corrupt branch of the federal government.
Yeah, I would advocate sabotage, subversion, as a last resort when political means fail.
Just because a dam has been sitting in a river for 200 years does not mean that it's going to stay there for the next 200.
All right. Now, I never advocate for showing anything before you watch it yourself. So make sure you, if you're interested in that you watch it yourself. There was some conversations that we had in our own district to make sure that video was appropriate to show in our own district. So I would recommend that you take it to whoever your curriculum council is to determine its appropriateness for your particular region.
And
Can you hear me?
Back to it, just with a thought.
Uh-oh.
I can hear you, but I think the video just restarted.
Uh-oh. All right. The other piece is just showing clips of the video. That might be enough because it is a pretty, it's a long video, but it's kind of a fun watch, particularly if you've got a group of mature students that can kind of handle those higher order thinking skills type questions. The other piece that we always emphasize when we watch this movie, and this was a part of that, is environmental principles and concepts number 5. There's no such thing as good people or bad people. It's multiple perspectives, and that's what makes environmental literacy such an interesting and robust topic, because there's lots of different perspectives and lots of different pieces of information that come together, and it's complex, and these issues are complex, but it's through conversation that we actually get somewhere together, understanding that what we're all striving is a healthier planet, both for natural and human social systems as well. That is basically it for the information that I wanted to share inside of those folders. And I wanted to, pass it back over. There is a Gots and Needs that I'd like to put up, but I don't know if Allison, if you want to say something while I'm looking for that Gots and Needs link.
Actually, I was just thinking about the damnation. I would highly recommend that's one that let me start my video, that's one that you use if you're going to look at environmental literacy. as Juanita has outlined it. I've even showed it at college classes, and it's been a very powerful tool. It's exactly what that lady said. When I first started teaching, I would say it's not, you need to think about this is the era of dam removal, that we have other ways in many cases to secure a water supply without impeding a river and ruining the environmental system behind it. And my students just found this shocking. They would be like, oh no, it's so ingrained in our consciousness, but that's not the case. And this is it's a really excellent film. So really, that's all I had to say about that. I'll catch back up with you once you go through your gots and needs, and then we'll do lingering questions.
Thank you. Yeah. So, yeah, it's hard to have a conversation if you haven't watched it. So, but it definitely makes conversations around these topics more interesting. Someone was talking about teaching environmental science, AP environmental science. It's those kinds of ideas that come up in AP environmental science over and over with the tragedy of the commons. The tragedy of the commons lab is actually also in the resources for this class as well, because it is, a natural resource that it's very tempting for everybody has a stake in it to just overuse it. It's all mine. So yeah, the little bit of Schmeagol comes out in all of us. Anyway, so inside of the chat, I've added in another Jamboard link, and this Jamboard is for gods and needs. And so if you would be so kind as to just click that link and add in a Post-it note with gods and needs are exactly what it sounds like. This is something that I got that I really appreciate from today. And this is something that I still feel like I need. And if you want to, if your need is very specific, then you can also put your contact info there, and then I can go back later on, or we can go back later on. The team, Dr. Steele and Allison and myself, can go back and try and get you what you need. So take a few seconds and fill out your gots and needs Post-its on the Jamboard. I think, let me see. Let me mute myself because my child is screaming things in the background.
Hey, where did we go? Days when the rains came down in the hollow, playing a new game, laughing and running, hey, hey, skipping and jumping in the misty morning fog with our hearts are thumping, and you, a bright girl. You, my brown-eyed girl. And whatever happened to Tuesday and so slow? Gone down the old line with a transistor radio.
Juanita, I don't think you're old enough to really have known this song when it came out. But it is timeless. It is timeless.
It's 100% timeless whenever it came out. I think we're almost done with the gods and needs.
Just like that.
All righty. Thank you so much for filling that out. And take your time. You can continue to fill it out at your convenience. I see that Patricia has a question in the chat. Has anyone heard if California is planning to build any more water catchments? Seems like we lose so much water to runoff and don't catch it when we can. And I think that there is a section inside the resources for these classes that talks about flood mitigation plans. And a lot of those flood mitigation plans take into account aquifer recharge, but I'm not sure if anybody else wants to say anything about that. And then we will.
Isn't the Sites Reservoir back on the table again?
I feel like it was, but Allison, do you know?
Yeah, I think it actually is. So there's two different ways to address the water runoff issue. A lot of cities actually capture every drop of water that lands within their city limits. For example, I worked in Upland. Every single drop of water that hits within the city of Upland is picked up and funneled to a catchment basin.
Mhm.
But some cities don't have the infrastructure dollars to build those extremely expensive systems. And then by law, remember, the environment has a co-equal goal with water. So if you don't let it run off to the ocean, you're starting to decimate rivers, streams, and ocean populations of fish. In California, the fishing industry is a huge commercial industry. Most of it being small family fishers rather than like agriculture, which is largely large commercial corporate farms. So there's all sorts of weighing out about how much water you let go out to sea, how much water you let leave your city. I live in Riverside. The Santa Ana River, every single drop of water in the Santa Ana River is already claimed by somebody. So even if it hits the Santa Ana River, it's already owned by somebody. So that's a really complex, and it depends on who's on the border. That could be a whole lesson in itself, depending on what it's like in your locality. So that's a really important question, and I appreciate that.
I'm in the LA Unified District, and there are no rivers. It's all cement, it's all been cemented over. So,
right.
And all that just runs out into the ocean.
Well, you have the LA River primarily, right? And the LA River, most of that, the LA River catchment, or the reason it was channelized the way it is, was to get water as efficiently as possible, as quickly as possible to the ocean.
Right.
You will find that is going to be removed over a period of time, and they are going to rebuild the river much as it was before they channelized.
That's awesome. That's awesome.
I think there's a nonprofit organization called Friends of the LA River that also does a lot of outreach and stuff, and is very willing to work with students to talk about some of the, indigenous Angelino stuff that happens with the LA River and stuff like that.
Absolutely.
Thank you.
So that question about catching water is one of the most complicated questions that you can ask in the water industry. And we could talk about it in a year and we would still not have an answer. You have people that have dedicated 20, 30 years to answering this question. And the big issue is, we can build all these massive dams, but the rainfall is inconsistent. So we could build all these dams. The biggest problem is when there's a huge rain event, we need to be able to move it off stream. So that's like a sites reservoir. In the Inland Empire, there's Diamond Valley Lake, which is an off stream reservoir. So that's like Southern California's emergency storage. There's some projects in Northern California. They've been called the Twin Tunnels. It's the Delta Conveyance Project. And basically it's a single purpose. It's when there's a huge rain event or flood event, they move the water out. So it's a complicated issue. And I think Juanita touched on it earlier when you talk about the different forms of, or I think Allison talked about it, like conservation is a big one. We have to all use as little water as possible. And building more dams is not always the answer. It's building off-stream storage and moving it elsewhere.
Oh yeah, I wasn't thinking about dams. I was just thinking about, other
runoff.
Yeah.
Yeah, it's like Bryce said, it's a real complicated issue. When it floods, you have to have enough capability to funnel water away from people's houses.
Right.
And you have to have somewhere off stream to store it. You have to let so much of it go down the river. I mean, Bryce is right. It's just so complicated.
Yeah, it seems like it.
It is. It is. We all ponder this all the time. We do.
In the chat, I went ahead and I added the Rialto USD resource folder. What I can tell you is that this is a living folder. All the teachers that teach out of it, they just make copies of the documents that they want. So it's a little bit messy, but you know, it's in there if you want, if you're in for some perusing.
Thank you, Juanita.
And that's it for me.
Wonderful job. Does anybody else have any questions before we go to Kathleen with a wrap up for the day?
I had a question for Juanita or Allison, potentially you. We currently teach solving water problems and water tech at Lawndale. And I have I'm just wondering how much the folder has been updated, because we got that folder from UCCI a bunch of years ago. And I think they've their mentorship program is kind of disbanded. So how much have you contributed, I guess? And then how much has changed over, and I know you said it's a living document. How much does that original folder change?
I actually don't know what was in the original folder, but I do know what's in the current folder, and there's tons of stuff in there. We had 3 different teachers teaching it, and so people were taking and moving and doing all that stuff, which is what I was telling Allison and Kathleen, that I was trying to change it up. Our scope and sequences have changed quite a bit, and one of the pieces is just trying to, instead of the Google folder idea seemed like a good idea at the beginning, but then when things start moving around, then it gets a little bit more complicated. But I think that there's tons more in the folder than was in that original. I know that there's a lot more than what was in that original UCCI, because as I recall, there was only like maybe three things per unit, because that's what was required for the grant.
That's correct. So that folder that Juanita so gracefully shared is going to be a lot more up to date than anything that, I worked on the original curriculum with Juanita, some other teachers over quite a period of time. We have not updated a lot of that material, but Juanita has, and other teachers have, as they've taught the class. And
the other thing was that we were unallowed at the UCCI to upload any material that we did not build. And in that folder, there's plenty of stuff that we didn't build. We just kind of found somewhere, and it was like, oh, this is really good, and I'm going to bring it in. Like the Concord Consortium stuff goes with the National Geographic, a whole set of lessons called Will There Be Enough Water? And so I know that is something that, just finding content like that. There's also a digital, we made a digital Flexbook using ck12.org. And those are free resources. And the Flexbook, the PDF version of the Flexbook, I think is also in there. We use that Flexbook we have a Flexbook for the year 1, year 2, and year 3 section. But the other thing to consider is also if your district has the funds to actually purchase the Sacramento State water book, the Sac State water, what's it called? It's a green book. It's the water operators manual or something like that. We purchased sets of those books for each of the classes as well, because the classes are intended to help them pass the water board certification, and the water board certification physically comes out of that book. So I don't know if you guys are teaching it as a science class or if you're teaching it as a CTE class, but having a separate, if you're really being honest about really trying to prepare the kids to take that test, you got to get that book.
We're working towards that CTE designation. I know we've been in a couple of the WIA. I've been in a couple of the WIA, and we're definitely not there. And that's my next question. With the CTE program that you have, are kids ready to come out of that and take that certificate test, the D1, T1, whatever it is.
Yeah, we're trying to get there. So this was the end of our third year. What we have mostly been working on and so it's the end of our third year doing this. And the third year kids, it was like during COVID. It was like, wah, wah, wah. So what we were trying to do is we were trying to just keep the kids engaged and try and get them some mentors at I'm trying to get one kid a job, like physically. That's my task in the next, I've been working on it for like 3 weeks, and we're all so close to having my success story from that cohort. But yeah, so we are working on it. The other thing is that what we found is that a lot of kids that took these sequence of classes, they were still college bound. They weren't necessarily just trying to earn the certification. So we got a lot of kids this past year who said that their declared major was going to be environmental science, environmental law, environmental engineering. Anecdotally, it was remarkable. So we're still working on it too, Dennis. Don't worry about it. We're all in this together.
Well, it's great. It's been confirming for me, to see some of those lessons that, because some of those lessons come right out of the folder, to see them and I've done them similarly, using the Jamboards and the CERs and all that other stuff, has been really, I've always felt like, and I know that there's only a handful of teachers that are doing it. Every time I've reached, and I believe you're the only person that I know of in Rialto that's doing the water courses. I'm not sure if anybody else is doing them, in my conversations with, and my connections with, NWD, West Basin, I'm here in the South Bay. And, and for folks that are in for first time, the water world is an interesting world that you don't know about. And there is a career, like you've heard people speak, there's careers there that our kids don't know about, and they're great careers. And I tell people when I meet them that I've been a teacher for 20 years now, and if I would have found out about the water world, the freshwater industry years ago, I don't know that I'd be a teacher. I think I would have went down that road. So there's the sell. But then again, I'm trying to figure out how do I get my kids, and it's funny that you have that success story to trying to get a kid a job. That's our goal, is we want to get a kid that comes back 5 years down the road saying, hey, I have my CT, my C or my P license, my D4 license, or or whatever it is. And
right, and I think too also, Dennis, that if nothing else, giving students an awareness of, like you said, who knew about the water industry? I didn't until I ran into that little brochure, and it was like, oh my God, this is such a great opportunity for students that aren't on the 4-year college track. Right. Yeah. And so providing them with an opportunity with some foundational knowledge and maybe an interest and an awareness that they can go to Valley College or they can go to the community college. Because quite frankly, you have to be 18 to take any of the water certification tests. And so that precludes a lot of students. And so even if they were old enough, we would recommend that they take a couple of classes at the community college level to prepare them more in depth with the certification process, which Allison, of course, is doing a wonderful job of that too.
Thank you, Kathleen. That's it. That brings us to an interesting thing. I start teaching again at Valley in mid-August, and it'll be my first dual class where I have high school students in it. And a friend of mine taught one last year, and he had high school students, so it was a dual immersion. So I'll be very curious to see how well it keeps up, because the classes are pretty rigorous. However, I think they'll be fine. I see that Tiffany uploaded the flyer.
Wait, hold on. Allison, before you go on, I just want to clarify something because you were using a term and I think you weren't using the term the same way that we use the term. You said it was dual immersion. And for
Yeah,
in the school system, that means it's in English and Spanish. And I don't think that's what you meant.
No,
You meant like a dual enrollment kind of situation where the high school and the university students can be in the same class.
Thank you, Juanita. Yes, you're absolutely right. Noted. Thank you. If anybody has any other questions, I see that Tiffany put the flyer for Thursday's class, which focuses on the CTE curriculum on Thursday rather than the biology, chemistry, and physics classes. But I would like to turn this over to Kathleen if there are no other questions for right now for a little wrap up.
Okay, well, I think we've covered an awful lot of ground today in just a very short period of time. Juanita is amazing, as you can see, and it's one of the reasons that I believe Rialto has done such a fantastic job with the water program is Juanita has been the driving force there. And it's her passion about environmental science that really helped us catapult this whole concept of how can we provide high school students an opportunity to learn about the water industry. And so Rialto is the place to watch. Juanita is the person to know. And I'm sure that we'll all want to continue keeping in touch with Juanita. I want to invite you also to attend Thursday. If at all possible, we'd love to have you attend. I believe somebody posted the flyer and the link to register. And so if you could do that, we'd love to see you on Thursday, where we are looking at the water industry more along the lines from a CTE, a career technical aspect. So I got to say, this has been the most exciting day I've had in a long time, because this has really been my dream. From the day I saw that brochure and being able to say, how do we connect young people to an opportunity to change their lives and the lives of their families without so many of our students are priced out of or are not able to attend a four-year university. And this is a wonderful opportunity for them to move forward, to support themselves and their family and join the middle class. And that's really our goal, is to provide opportunity for everyone. Juanita's amazing, as you know now, why we all love her. The science was way over my head, but thank you for making it comprehensible for someone like me. I appreciate that. And I hope that the teachers in the room will utilize the folder and the resources and the activities that we talked about today. What else do I want to say? I want to say, first of all, thank you, Juanita. Thank you, Allison. Thank you, Bryce, for driving the car for us. It was almost seamless.
Yay! Thank you, Bryce.
Bryce. This is our first time out the gate with this particular training, and I hope you found it valuable and you'll utilize it in the future. And that's all I have to say, Allison. It's back to you.
Okay, I'm typing in something into the chat. So the next thing we have, Bryce, if you could please move forward one, is, we have a little reflection, right? And I need this information from you. It's a very short survey. I think there's 5 questions. I'm going to ask that you give me your name and your address and your email. That is how we will see who attended, but also so I can mail you your goodie bags and your gift card, right? I need that information. So I'm the only one who's going to have it. So the link is at the bottom. And thank you, Bryce, for putting that on there. And as soon as I get the majority of them in, I will get that stuff out to you. Yeah, that's it. It's very simple. Go ahead.
One more thing.
Sure.
One more thing, Allison. So before we leave, if it's all about me and Juanita and Allison, we just want to hear how wonderful we were, really. So we'd love just to have like a little popcorn, just unmute your mic and just tell us in a couple of words if you found it valuable, and we hope to see your faces again.
Absolutely. And then I do have one thing on which I will discuss on the next slide. Bryce,
Okay.
if you could move forward for me real quick before I forget, because we're getting close on time. So I'm going to send you an additional survey in about 6 months if you attended, mostly because our sponsors would like to know if you've implemented anything that you've learned today in your class. We're going to make it very simple, just like, hey, how are you? You know, what have you got going on? What's worked for you? What didn't work? So you can expect to hear from me again in another 6 months. There is my contact information as well if you need anything. And now we can, now that I made sure I got everything, it'd
Sorry.
be great. No, it's no problem. If you would unmute yourself, tell us what you thought maybe was most useful, or maybe.
Wait, can I just interject one really quick thing?
Sure.
And that is, there was a request in the needs from the Gots and Needs poster that was asking for statistics on water reservoirs, and inside of the folder, in the Rialto USD folder, there is a resource that's California Water Maps. And actually that resource, even outside of the folder, if you just look up California Water Maps, I think you'll find additional pieces, additional information there that you can download. It's a PDF. There was also a request, so just that I say it out loud for the recording or whatever, for the water, a list of the water companies in California, so that perhaps, I'm assuming that that need was so that they could reach out to those water companies, and so it would be a resource that would make that easier, which sounds great. Resources like field trips and speakers and guest speakers. There were a couple of requests for access to those people. And sorry, guys, you got to reach out to your own people. But once you reach out to them once, they tend to be really super friendly, and they'll stay in touch for the future.
Yes, Juanita's right. You're going to have to find out who your own water purveyor is and reach out to them. Everybody has different tour requirements, whether they even give tours. Most places do give tours. As for a list of all water purveyors, I'm not actually aware of that list existing. Maybe on the State Water Resources Control Board. I can take a look and send out a short email, but I think that's, you know, there are so many mutual water companies. There are 50,000 water providers in the United States. So in California, between the mutual water companies, the private organizations, the public organizations, irrigation companies, that may be a lot, but I'll look. So I'm gonna write that down right now. Does anybody, there's a question on here. So what will the bag include? I'm not exactly sure yet because I'm picking it up tomorrow afternoon. I know that MoDOC, WIA, and Metropolitan have all put items together for the goodie bag. So it'll be a surprise when it gets to your house.
And there's the gift card, Allison, too.
$50 gift card. That's right.
There we go.
$50 gift card just for attending today. But you've got to please fill out that survey so I have the information to send it to you. Does anybody else have anything else they would like to add?
You guys were great. I learned so much. I mean, I knew some of the strategies, but the little stuff that you added will be helpful, because I teach both ESL, our English language learners, and I have 2 AP classes. So.
Oh, nice.
Damn it.
Nice.
Yeah, thank you.
Anyone else?
As usual, the problem child cannot get in the survey. Is it on? What did I do?
I'm not sure, Clover.
I don't see it.
I am going to send out an email, though.
I'll answer it via that way then, because I don't.
Is anybody else having that difficulty, or maybe they haven't tried yet?
I saw it and then it just went away, but I thought I had done something. Let's see here. Let's see here. I've got it now.
Yeah, mine came right up.
Okay.
Mine came right up.
Can I ask a real quick question?
Sure.
Okay, look, I'm going to be teaching in a few weeks in a continuation school. Usually the kids there are not, what would you call, the highest achievers. So I was thinking of, so a lot of them are ELD learners. So it looks like there's a lot of ELD teachers. I was thinking of using WordWall. DOK questions at a low level and other strategies. And I was thinking, is there something that can be utilized for science teachers? Because, the book that we're using is very thick, and I think this is covering one of the chapters, but that's about it. So I was wondering, what other strategies do you suggest for students that need support?
Juanita?
Yeah, there's the tiered vocabulary system. The FRAIR model, I think, is a good strategy for English language learners. So the FRAIR model has the vocabulary word in the center. You've got the definition, an example, a non-example, and an illustration. That's always helpful. I would also suggest using some sites like News ELA in order to find or to be able to modify text to different Lexile levels. So you can change the text Lexile of whatever document that you're looking at. A strategy that is recommended in the California Framework for Science Instruction is not changing the Lexile, but instead changing the quantity that you ask the students read. So while you might ask a student to read like the whole unit or lesson, in a regular class, if you are looking for, if you can boil it down to like 2 to 3 paragraphs, research says that even if the Lexile is very high, if the quantity of text is low, then it makes it more accessible to students. The other piece is having students talk about the text. When students are given the opportunity to discuss the text, so almost like a jigsaw activity or what's it called? A reciprocal teaching. Have you ever heard of reciprocal teaching, Juan?
It used to be around years ago.
Yeah, so reciprocal teaching is also as a very useful strategy as well. So those are
I was wondering, they used to, and they still have I can understand or I can state standards for elementary and middle school. Are there some of those for senior or, high school that you've seen around?
I have not. And I think it's mostly because the standards are written as performance expectations. There are some like I can statements for the science and engineering practices. So if you wanted to break up if you were going to focus on anything in your science class at the continuation school, I would focus on the science and engineering practices. So if you can get those 8 practices, use the DCI as the context to teach the practice. Those are the transferable skills.
All right. Thanks. Appreciate your input.
Yeah, of course.
Okay.
I want to say that these courses, the water courses, would do double duty at the continuation school. So if you are able to teach the water courses, I would highly recommend it. That's what we are recommending in our district because it gives the students both the science and the CTE. They're considered CTE completers. So talk to your principal about your college and career readiness indicator and the courses because it would really do double duty for your kiddos.
I'll keep it in mind. Thanks.
Okay, I think that wraps us up for today. I hope that I see some of you again, at least on Thursday. Thanks again to our sponsors, MODOC, WIA, and Metropolitan Water District. And thank you guys all for coming so much. Hope to see you Thursday. Have a wonderful afternoon.